Hi friends, my name is Maruti and I am the co-founder of Kraku. In this video, we'll be looking at 20 very important formulas for CAT. Initially, Sayali will explain the formula and after that she will solve one question which is based on that formula so that you can understand the applications of the formulas also quite well. All these formulae will be very useful for all the MBA exams like CAT, XAT, IFT and all of them. We do have the previous papers for all of these MBA exams. If you're looking for previous paper PDFs for CAT or XAT or IFT or CMAT or SNAP, you can download them at Kraku. In addition to that, I want to tell you that as CAT is approaching, you have to take as many mocks as you can. Kraku's dash CATs are of very good quality. All the questions will be of similar level as can be expected on the day of the examination. All the questions have detailed video solutions. So I would highly recommend you to take Kraku's dash CATs.
Hi friends, welcome to Kraku's video series. I'm Sayali. In this particular video, I'm going to be revising 20 important CAT formulas that you should remember going into the exam. So I'm basically going to cover those CAT quant formulas which you need to remember, which are very important for the exam, but most students tend to forget. It is basically the formulas that are important but not used as frequently as most of the other formulas, but are still very important to remember when it comes to CAT quant exam. So let's take a look at the first formula. So we'll start with number systems. So the first important formula that you should remember is for number of factors. We'll begin with the very beginning with the number systems. The first thing that you should do with number systems is know what is prime factorization. Prime factorization is basically converting the number into a product of prime factors. So saying this is equal to a raised to p into b raised to q into c raised to r and so on, where a, b, c are prime numbers. So for example, if you are considering n is equal to say 80. If n is equal to 80, what is the prime factors of n? That is essentially equal to 16 into 5. So this is basically 2 raised to 4 into 5. 2 raised to 4 into 5. So basically first thing that you should know about this is how to do prime factorization like this, where you convert the number into product of prime numbers. So 2 is a prime number, 5 is a prime number. So you convert it into a product of powers of prime numbers. So once you have this, the number of factors, formula for number of factors is number of factors of n is equal to, this is equal to p plus 1 times q plus 1 times the product of p plus 1 into q plus 1 plus r plus 1 and so on. So how do you actually get this formula? See, whenever you have to consider what are the factors of any number n, you say that okay, 80, it is 1 into 80, then 2 into 40 and so on. So to get all the list of factors, you have to consider how many numbers are basically have a subset of the powers of the same factors. So in this case, basically you have to consider that okay, neither 2 nor 5, any power of 2 nor power of 5, so that will give 1. Only just 1 power of 2, you will get 2 as a factor. Then if 2 raised to 2, you get 4 as a factor and so on. So basically the job of forming a factor is a job of selecting from 2 raised to 4 into 5 raised to 1 some power of 2 into some power of 5. So in how many ways can you select a power of 2? So the power of 2 can be selected from 0 to 4, that is 5 ways. So this will basically be 2 raised to 0, 2 raised to 1, 2 raised to 2 and so on till 2 raised to 5. In how many ways can you select a power of 5? That can be done from 0 to 1 ways, that is basically 2 ways. So that can be 5 raised to 0 and 5 raised to 1. Now if you multiply these two together, you get all the individual factors of 80. So 2 raised to 0 is nothing other than 1. Similarly 5 raised to 0 is 1. So 1 into 1 will give you the factor 1. 2 raised to 1 into 5 raised to 0, that is 2. 2 raised to 2 into 5 raised to 0, that is basically 4. 2 raised to 1 into 5 raised to 1 is what? It is 10. So to get each individual factor, you have to consider a power of 2 into power of 5. So in general, when you have a raised to p into b raised to q into c raised to r, the number of ways of selecting the powers of n would be p plus 1. This plus 1 comes because the number of ways are selecting from 0 to p. So 0 to p is total of p plus 1 ways. So p plus 1 ways for selecting power of a, q plus 1 ways of selecting power b, r plus 1 ways of selecting power c and so on. So the total number of factors that you get is this. Now a subset of this concept is to get the number of even factors and the number of odd factors. So how would you get the number of even factors? Basically in this case you have to say that suppose n is of the form 2 raised to p into b raised to q into c raised to r. So instead of a, I am assuming the first prime factor is 2. So if that is the case, what you have to say is that to get even factors of n, I have to at least pick one power of 2. I can't pick 2 raised to 0 as a power of 2, which would mean that instead of p plus 1, I'd have p possible ways of selecting the powers of 2. This into q plus 1 into r plus 1. This will give you the number of even factors. Similarly, if I have to get the number of odd factors, what would I do? I'd say that I can't pick any power of 2 other than 2 raised to 0, which is basically 1. Then you have to basically consider all the odd factors of 2 would be b raised to q into c raised to r, factors of b raised to q into c raised to r into d raised to s, etc. And so on. So that would be basically 1 into q plus 1 into r plus 1 and so on. Basically here you pick the only power of 2 that you are picking is 2 raised to 0, that is not a even power. So this is the number of odd factors. Essentially you have to remember what is the concept of number of factors. The number of factors concept is basically the number of ways of picking factors of a particular number. So the number of ways of picking a factor of a is p, a raised to p is the power of a in n. So I can pick powers of a in 0 to p, that is p plus 1 ways. So once you understand that, when you put the condition that it has to be even factor, I can't pick 2 raised to 0 as one of the powers. So then it becomes p into q plus 1 into r plus 1 ways. Similarly, if I say that it has to be odd factors, then I can't pick any other power of 2 raised to p other than 2 raised to 0. So it becomes 1 into q plus 1, r plus 1 and so on. Just remember this concept that you have to pick powers of each of the prime factors. The number of ways of picking the powers, you have to multiply them together to get the number of factors. We will solve a slightly more like essentially just one more step forward kind of a question based on this topic, and it is something which can definitely come in CAT because it just uses a conceptual knowledge that is underlying the concept of number of factors. So let's take a look at that particular question. So if you consider the question that is given over here, here we have n is equal to 2 raised to 8 and 9 square into 5 cube. Then the number of factors of n which are multiples of 25 is what? Here we have to consider multiples of 25. So it's not just number of factors, but number of factors which are multiples of 25. So in that case, what is the bare minimum power of 5 that you have to select? See, in this case, the number of ways of selecting powers of 2 will be from 0 to 8, that is 9 ways. In how many ways can you select powers of, this is 9, 9 will basically be 3 square into 2, so this is basically 3 raised to 4. So this is 2 raised to 8, instead of 9 we have to put prime factors, you can't put composite numbers. So this is 3 raised to 4 into 5 cube. So in that case, what if this is 3 raised to 4, how many ways can you select powers of 3? You can select from 0 to 4, that is 5 ways. Now how many ways can you select powers of 5? See, because you have to have them as multiples of 25, there are 4 powers of 5, 5 raised to 0, 5 raised to 1, 5 raised to 2 and 5 raised to 3. Since it has to be a multiple of 25, we can't consider the 5 raised to 1 and 5 raised to 0. We have to consider only these two possible powers of 5. At least we have to select the bare basic index for the factor that we have to select is 5 square. So basically how many ways can we select the powers of 5? That is 2 to 3, that is 2 ways. So what is the total number of factors? Number of factors is 9 into 5 into 2. 9 into 5 into 2 is 90 ways. So how many such factors are there such that they are multiples of 25? There are 90 such factors. So the right answer is option C. So if you remember that this is just basically selecting the number of ways of selecting each of the prime factors, it becomes very easy to solve this particular type of question. Now let's go back to our next formula. Our next formula that I will cover is that of number of numbers less than n which are co-prime to n. So many of the remainder theorems questions don't come anymore, but what do actually come is basically you have to count the number of numbers which are co-prime to a given number. This uses the Euler's Totient function, which is part of Euler's theorem, but even if Euler's theorem doesn't come as a remainder theorem anymore, the Euler's Totient function has value in number systems because that comes as part of counting the number of numbers that are co-prime to a given number. So firstly, what is co-prime? So consider the numbers 4 and 9. Are each of these numbers prime numbers? No, neither of the two numbers is a prime number. But 4 is co-prime with 9. So when you say some numbers m and n are co-prime to each other, what you're basically saying is that the highest common factor of 4 and 9, this is equal to 1. To find highest common factor, you have to find out which factor is common between these two, and the only factor which is common between 4 and 9 is 1. Which means that the HCF is 1, which means that 4 and 9 are co-prime to each other. So that is the basic understanding of what is co-prime. Now Euler's Totient function, that is phi of n, gives you the number of numbers which are less than n which are co-prime to n. So for example, consider n is equal to 100. Suppose you are asked how many numbers from 1 to 100 are such that they are co-prime to 100. If that is the question, how do you actually find out? You can't actually start counting, right? So there has to be some way of figuring out how many numbers are there such that they are less than 100 and are co-prime to 100. The way you need to do this is you have to first factorize, prime factorize the number. So this is 100 is basically 2 square into 5 square. Once you have the prime factors, suppose n is of the form a raised to p into b raised to q into c raised to r and so on. The way you find out the Euler's Totient function of n, this is equal to n times 1 minus 1 upon a into 1 minus 1 upon b. This is the Euler's and 1 minus 1 upon c and so on. This is the Euler's Totient function of n. So what is Euler's Totient function of 100? That would be basically 100 times 1 minus half into 1 minus 1 by 5. So this is equal to how much? This is half into 4 by 5, that is 2 by 5. So this is equal to 40. So phi of 100 is equal to 40. So what does this mean? That we found out that the Euler's Totient function value of 100 is 40, but what does it mean? That means that there are 40 numbers which are less than 100 and are co-prime to 100. Similarly, you can do that with any number. Suppose say n is equal to 49. So if n is equal to 49, this is equal to 7 square. So similarly, you can say phi of 49 is equal to 49 into 1 minus 1 by 7. So that is equal to 6 by 7. So that is equal to 42. So there are 42 numbers which are less than 49 which are co-prime with 49. Now if you think of it logically, you can write 1, 2, 3, 4, 5, 6 till 10 till 49, okay. Essentially, you will be removing only the 7 numbers which are multiples of 7 which are less than 49. So you will be ending up with 42 numbers which are essentially co-prime with 49. So this Totient, Euler's Totient function, even if Euler's theorem doesn't come often as part of remainder theory, it does come as part of finding the number of numbers which are co-prime with a given number n. So always remember this. In case you are wondering what Euler's theorem is, just to mention it because we have touched upon it, according to Euler's theorem, you will find phi of n like this. If m and n are co-prime to each other, then m raised to phi of n mod n is equal to 1. That is the remainder when m raised to phi of n is divided by n is 1. That is, you basically can find out any remainder, complex remainder question by saying that this raised to this mod of n is equal to 1. So if you have to, for example, if you have to find out what is 3 raised to 400 mod 100. I know that 3 and 100 are co-prime with each other. There is no factor common between 3 and 100. So that would mean that 3 raised to 40, because phi of 100 is 40, 3 raised to 40 mod 100 is 1. So 3 raised to 40 mod 100 is 1. So this can be split up into 10 parts of 3 raised to 40. Each of them mod 100 would be 1, which means 1 into 1 into 1. So 3 raised to 400 mod 100 would also be 1. That is just in, I am just revising Euler's formula also, Euler's remainder theorem also. In case you want to see that, look it up, but remainder theorem questions are less important. But it is still important to remember the Euler's Totient function for these specific type of questions. So now that you know the formula for Euler's Totient function, let's take a look at a question based on it. So let's consider the second question. So the second question is, how many 1-digit and 2-digit natural numbers are co-prime to 200? So you have to find out how many 1-digit and 2-digit natural numbers are co-prime to 200. So you have to find out from 1 to 99 how many numbers are co-prime to 200. So we have the formula for what is co-prime to 200 and less than 200. But that also includes these like numbers from 100 to 199. But we don't want that. We want only from 1 to 99 as such. So what should we do? In this case, basically you have to remember that if you consider 100, 100 is equal to what? This is 2 square into 5 square. And what is 200? 200 is equal to 2 cube into 5 square. So if any number is co-prime with 100, it will also be co-prime with 200. There is no number that can be co-prime with 200 but not co-prime with 100. So instead of figuring out how many numbers, single 1-digit and 2-digit numbers are co-prime with 200, we figure out how many numbers are co-prime with 100 and less than 100, because we have a direct formula for that. So instead of finding out the number of Euler's totient function value for 200, we do that for 100, and once we have that, we have the answer for how many single digit and 2-digit natural numbers are there which are co-prime to 200. Because if a number is co-prime to 200, it is also co-prime to 100, and if it is co-prime to 100, it is also co-prime to 200. Both of these have the same exact set of prime factors. 2 is a factor, 5 is a factor. So if any multiple of 2 or 5 is there, that number will not be co-prime to 100, nor will it be co-prime to 200. So once you have that, we can now go on and say that how many single digit and 2-digit natural numbers are less than 100 and co-prime to it. So that will be basically phi of 100. Phi of 100 we just found out to be 40. That is basically, how did we find that out? In case you miss, if you go back, this is 100 into 1 minus 1 by 2 into 1 minus 1 by 5. If you multiply this together, you get 40. So phi of 100 is 40. That is Euler's totient function value of 100 is 40, which means that there are 40 single digit and 2-digit numbers which are co-prime to 100, which means that there are 40 single digit and 2-digit numbers which are co-prime to 200. So the right answer is 40. Now let's go back to formulas. So now let's consider the next formula. Here we are going off to algebra, and algebra I am actually, you would consider AMGM property to be part of number systems, and it is there as part of number systems as such, of numbers and understanding arithmetic mean, geometric mean and harmonic mean, but its application mostly comes as part of algebra questions. So in many cases what is actually asked is, you are given an algebraic equation and you are asked what is the minimum value of it or what is the maximum value of it. To find out the minimum value or the maximum value, you can use this particular inequality to find out the minimum or maximum value. So how do you actually do that? According to AMGM property, when you have a set of numbers which are positive numbers, so for example if you have 1, 2, 4, 8 and so on, the arithmetic mean of positive, it has to be positive, okay? It cannot be negative. Arithmetic mean of positive numbers will be greater than or equal to geometric mean of the positive numbers, which will be greater than or equal to the harmonic mean of the positive numbers. So what does this mean essentially? This essentially means that if you have a question where you are given, the arithmetic mean, suppose you have these mean, the arithmetic mean 1 plus 2 plus 4 plus 8 divided by 2, this will be necessarily greater than or equal to the geometric mean of that. So that is 4th root of 1 into 2 into 4 into 8. That is the basic idea of arithmetic mean and geometric mean. To find out arithmetic mean, you have to basically take the sum of all elements xi divided by n. To find the geometric mean, you have to take the nth root of the product of all xi. So 1 into 2 into 4 into 8, and nth root of that will give you the geometric mean. So according to the property AMGM property, this value will always be greater than or equal to the GM value as such. Mostly what you need for solving questions is this part. The HM part rarely comes. Now how does this come into play in the algebraic questions? See, in algebraic questions what will be given is that you will be given a fixed value for the sum. So for example, you will be given that say a plus b plus c is equal to 20. The sum is given and you will be asked what is the maximum value of a, b, c. So if you have to find out the maximum value of product such that the sum is given, you have to use the AMGM property, because this value, the ABC divided by 3, this divided by 3 should be greater than or equal to the cube root of the product. So basically that gives you what is the maximum possible value that the geometric mean can take. Also remember, AM is equal to GM only when all of the elements are same. So if you get that AM is equal to GM, then basically means that all of the values A, B, C have to be equal. In case that they have to be integers, then they will be as close to each other as possible. So when you have AM is greater than or equal to GM, you get basically an upper limit for what the value that the geometric mean can take. So if you are asked what is the maximum of product given the value for the sum, you have to use AM-GM property. If you are asked what is the minimum value for A plus B plus C given the value of the product, if you are asked minimum value for sum given the value of the product, again you have to use the AM-GM property, because in here what you have to basically say is that the lower bound for the sum is equal to the max value that can be taken by the geometric mean. So the product sets the lower bound for the sum. So if you have to find out min value of sum, remember AM-GM property. If you have to find the max value of a product, you have to remember AM-GM property. This will be like the application in algebra will be clearer with the help of an example. So just remember, in most algebra questions, whenever you are asked for min or max, min of sum or max of product, you have to use the AM-GM property. According to AM-GM property, sum of all elements, positive elements, very important to remember, here xi have to be positive. Sum of xi, that is basically all the values of inside that set, sum of all elements inside that set divided by the number of elements n, this has to be greater than or equal to nth root of product of all elements. And when does equality occur? Equality occurs when all the elements of the set are equal. So that is the basic point that you have to remember when it comes to AM-GM property. Now let's take a look at a question based on this.
Google search crack your free CAT mocks. Click on the first link. You can attempt 3 latest mocks in the actual exam interface. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solutions to get video solutions from our expert faculty.
So let's take a look at the question. The question is, the minimum value of 4 raised to sin x plus 4 raised to cos x is what? So in this particular case, we are asked the minimum value of a sum. So by AM-GM property, we know that 4 raised to sin x plus 4 raised to cos x divided by 2, which is the AM, has to be greater than or equal to square root of 4 raised to sin x into 4 raised to cos x, the product, square root of the product. So if I take the required sum 4 raised to sin x plus 4 raised to cos x greater than or equal to 2 times this square root, which is basically this will be equal to 4 raised to sin x plus cos x by 2. Now this value, essentially the least value that you can have is this has to be greater than or equal to 2 times 4 raised to this. If I take this as 2 square, that this cancels off, so I can write this as 2 times 2 raised to sin x plus cos x. Now what is the least possible value of sin x plus cos x? So I know that in this case basically the least possible value of sin x plus cos x will give you the least possible value of 2 raised to sin x plus cos x, which in turn will give you the least possible value of the left hand side. So in this case, what is the least possible value of sin x plus cos x given any value of x? See, if you know understand, sin x is essentially the y coordinate. If you have any point and this is say theta, then the x coordinate is cos theta, and suppose this is 1, the x coordinate is cos theta and the y coordinate is sin theta. So essentially if I have to consider what is the least possible value of sin x and cos x, I know that this keeps on moving around the circle, and the least possible value occurs when you have sin x and cos x in the third quadrant, when both are negative, and essentially this it will occur when both are equal to each other, the least possible value as such. So that occurs when it is equal to, this is basically over here where you have this angle, if it is equal to 45 degrees, then you have this is equal to minus 1 by root 2 and minus 1 by root 2, and the least possible value of sin x plus cos x is this sum of these two, which is minus 1 by root 2 plus minus 1 by root 2, that is minus 2 times divided by root 2, so that is equal to minus root 2. That is the least possible value of sin x plus cos x. So if I put in that value, I get this is greater than or equal to 2 times 2 raised to minus root 2. This is the least possible value that this can take. That is when you have, this is 180 plus 45. That is when x is equal to 225 degrees. When x is equal to 225 degrees, this sum is equal to, each is equal to minus 1 by root 2, and this sum would be equal to minus root 2. So this means that this is greater than or equal to, this is 2 raised to 1, so this is 1 minus root 2. And this least possible value occurs when x is equal to 225 degrees. To find out this value where you get the least possible value of sin x and cos x, remember that happens when both will be negative. This is the first quadrant when one is positive, one is negative. That will not give you the least value. In this quadrant, cos is negative, sin is positive. In this quadrant, both are negative, and in the fourth quadrant, cos is positive, sin is negative. So to get the least possible value of sin x plus cos x, you have to consider the third quadrant, and when they are equal to each other, we get the least possible value, which is minus root 2. So in this way, I got the least possible value of the sum occurs when x is 225 degrees, and that is 2 raised to 1 minus root 2, that is option D. Always remember in such cases, as far as possible, as I said, the least possible value, also one more thing that you should remember is that the minimum value of this arithmetic mean will occur when both are equal to each other. Even that should be a clue to you that sin x and cos x should be equal to each other, and at that point of time only you will get arithmetic mean. If these two values are equal, then AM is equal to GM. Otherwise, AM will be always strictly greater than GM. So from that also you should realize that sin x has to be equal to cos x, and the quadrant where sin x equal to cos x you can get in the third quadrant, that is when it is minus 1 by root 2 minus 1 by root 2, which gives you the least possible value for sin x plus cos x, which in turn gives you the least possible value for this particular sum. Always remember this basic property. Whenever you are asked the minimum value of a sum, you have to remember this. Whenever you are asked the maximum value of a product, you have to remember this. Now let's get back to our so we had the AM-GM-HM property. Now another algebraic property that is used fairly often, firstly mostly as part of quadratic equations, but in case of all polynomial equations, that is sum of roots and product of roots. So consider your normal quadratic equation. You have say ax square plus bx plus c equal to 0. So what is the sum of the roots? Suppose the roots are alpha and beta. Alpha plus beta is equal to minus b by a. Now what is the product of the roots? The product of the roots alpha beta is equal to c by a. But in fact it is a more general property for any polynomial equation. So suppose you have ax raised to 4 plus bx cube plus cx square plus dx plus e, and this equal to 0, and suppose the roots are alpha, beta, gamma and say delta. So in this case the sum of the roots alpha, beta, gamma, delta, the sum of the roots, this is equal to the value of basically x raised to n minus 1, the coefficient minus of that divided by the value of coefficient of x raised to n. So this again will be minus b by n. So you have to take the second highest exponent in that polynomial equation. So this has to be only with one variable. In that variable, so if you have x and y, equation in x and y, this doesn't apply. It has to be an equation with like different indices with the same variable as such. So in that case, the sum of the roots will be equal to, like if you have like ax raised to n plus bx raised to n minus 1 and so on, sum of the roots will be minus b by a. Always the second coefficient minus of the second coefficient divided by the first coefficient gives you the sum of the roots. Now this is a alpha, beta, gamma plus delta, that is equal to minus b by a. Now the sum of the roots taken two at a time, that is basically alpha beta plus beta gamma plus gamma delta plus alpha delta plus beta delta, this is 1 2 3 plus alpha beta beta gamma, so and alpha gamma. So these 6 like 4C2 essentially, the sum of the product of the roots taken two at a time, this is equal to the third coefficient divided by a. So in this case you have to alternate the sign. So the first coefficient is negative, then it is positive, then again negative, then again positive. So in this case you have positive c by a. This is the sum of the roots taken two at a time. Now in the case of if you have only x square, it is basically equal to the product. But essentially that is because there are just two roots, that's why it's equal to the product. Otherwise it is the products taken two at a time, the sum of the products taken two at a time. Now if you take it at 3 at a time, then alpha beta gamma plus beta gamma delta plus alpha beta delta plus you have alpha gamma delta. This sum of the products taken 3 at a time, this is going to be equal to, this is minus, this is plus, this is now minus. So this is minus d by a. So each time essentially you get the sum of the roots taken 1 at a time, sum of the roots with products taken 2 at a time, sum of the product of roots taken 3 at a time, and so on. Finally, the last term will be basically sum of all the products. So this will be alpha, beta, gamma, delta. This is equal to, this is minus, this is plus. So that is E by A. So every time you see that this is minus, plus, this is sum of the roots, this is sum of the product of roots taken 2 at a time, sum of the product of the roots taken 3 at a time, sum of the product of the roots taken 4 at a time. But 4 at a time means product of all 4 roots, which is just only one value. So that is the format. In general, you can write this as, suppose your equation is ax raised to n, ax raised to n plus b x raised to n minus 1 plus c x raised to n minus 2 and so on. This is equal to 0. You can write the sum of the roots. Sum of roots is what? Suppose sum of this is alpha I. The roots are alpha 1, alpha 2, etc. The sum of the roots is minus b by a. The sum of the roots taken 2 at a time, that is alpha I and alpha j. This sum where I goes from 1 to n. The sum of the product of the roots taken 2 at a time, this will be equal to, this will be the second part. So this will be c by a. Then minus d by taken 3 at a time will be alpha I, alpha j, alpha k. This product will be equal to d upon a minus d upon a and so on. In general, the last term will be basically, if it is, this is minus plus, minus plus. So if n is a even number, if n, the value of n is an even number, it will be the last term, that whatever is the last term divided by positive value of last term divided by. If n is an odd number, it will be minus this of the last term divided by. So essentially you have to consider minus this raised to n, the number of terms taken at a time, divided minus 1 raised to say k, where k terms are taken at a time, that into the coefficient, the respective coefficient divided by a as such. So minus b by a plus c by a minus d by a plus e by a minus f by a and so on. That gives you the sum of the products taken k at a time, that is 1 at a time, 2 at a time, etc. So now that you understand this basic concept, let's go back and solve a question based on it. So consider the following question. For what value of a is the sum of the roots of the equation equal to 2? So what is the sum of the roots of the equation? In this case, alpha plus beta, that are the roots of the equation. This will be equal to minus of a minus 3 divided by a. Now this is equal to 2. So this is essentially 3 minus a by a is equal to 2. That is 3 minus a is equal to 2a, or rather 3a is equal to 3. So a is equal to 1. So the only value of a where this is equal to 2 is when option A is equal to 1. A pretty simple question and an indicative of the formula, but remember this in general. So if it was a similar equation but you had like them taken 2 at a time or taken 3 at a time, then you will basically have to choose the appropriate coefficient divided by the first coefficient, plus minus sign, just take care of that and you will get the answer. Pretty simple formula, but it is very important to remember in these kind of questions. Now let's go back to this, and now we'll go to mixtures and solutions. Now mixtures and solutions comes very often in CAT, and it is one of the most important topics when it comes to CAT. Especially this serial replacement of a solution occurs so many times in CAT that it is something that you should know by heart, and it should not be something that you have to actually solve. You should be able to quickly find the answer. That is very important. So there is a quick formula to finding the answer for replacement of solution. You need not know this formula, you can solve it without knowing the formula as well. But the point is that if you know this formula, it saves a lot of time when it comes to solving. See, remember, when you have replacement of solution done n number of times, say suppose you have a solution, 100% solution, so you have an existing solution essentially. I will take an example first actually. So if you have a solution where you have say sugar solution where you have 40 grams of sugar the concentration by weight, say 40 grams of sugar for 100 grams of water, or rather 60 grams of water. So we have a 100 gram solution. So you have 60 grams of water. This is the initial solution. So this is like a 40% strength by weight sugar solution. So in this case, suppose you have the fact that from this sugar solution certain amount is taken out and replaced by water, and this again it is taken out and replaced by water, and so on. So what happens each time you take out some part of it and replace by water? The amount of sugar keeps on going down, because you are removing some part of sugar plus water and only adding back water. So suppose you had this 100 gram solution, and suppose you took 10 grams out and added 10 grams of the solution out, and you added back 10 grams of water. This is one step. Then you did the same thing another time, you took 10 grams of solution out. After this first step, again added 10 grams of water, again took 10 grams of like the resulting solution, and again added 10 grams of water. So each time you are doing that, the level of sugar solution is keeping on going down. So in this case, you will be asked either that is what is now the new concentration of the sugar solution, or how many units of water are there in the solution, or what is the ratio of sugar to water in the solution. In this case, you can do this like step by step. You can say that okay, if it is 40 grams sugar, 60 grams water, after the first step there will be 4 grams sugar will go, 6 gram water will go. So this will be 36 grams sugar, and first when it is deducted 6 grams will go, so that will be 54 grams of water. Another 10 grams are added, so this will become 60 grams water. This is the solution after the first step. Then again you take out 10 grams, so this will be 36 minus 3.6, so that would be how much? That would be 32.4, and this would be the remainder as such. So this you can keep doing to find out the resulting solution, but essentially this is kind of time consuming. There is a easy way to find out the answer in such a case. Basically what you have to say is that instead of focusing on the concentration of water that is added back or anything that is added back, ignore the part that is added back. You just figure out the concentration of the solution that is just removed but never added back. So for example, in this case, you are removing in each step, you are removing 10 grams of solution and adding back 10 grams of water. So in each case, some part of the sugar solution with each step is going down. How much part of the sugar solution is going down? So 10 grams out of 100 grams of the solution is being removed in each step. So 90 grams of the solution remain in each step. So in the first step you get 90 by 100, that is the amount of solution that is not removed, divided by the total amount of solution, that into the initial concentration. So this will give you the value of sugar solution after the first step, because sugar is not being added back. Now after second step you will have 90 by 100, the whole square into 40 grams. This will give you the amount of sugar in that solution after two steps, because in each step, okay, 90% of the solution remains untouched, and that is where the sugar lies. So each time you are saying that okay, 90% of 40 grams, then 90% square of 40 grams, 90% cube of 40 grams. In general, basically what you have to say is that focus only on that part where the which is not being added back, find out the concentration of that part. So you say whatever is V and say T. V is the amount of solution that is not touched. So suppose of say 1 liter 100 ml is removed. If out of 1 liter 100 ml is removed, then 900 ml is not touched. So in this case V will be 900 ml. And total volume T is the total volume, which will be T will be 1 liter. So V by T times N, N is the number of times this step is carried out. So once if it is done, it is 1. If it is this step or replacement of solution is done twice, it is 2, 3, 4. It is N done N times, you have to raise it to N. This into the initial concentration will give you, or initial quantity will give you the final concentration or quantity. So what is the this over here? So essentially you have to take the part or the ratio of the part that is not touched to the total volume, and this ratio, essentially this percentage, has to be multiplied with the initial concentration n number of times to get the final concentration. So in our case, basically if this step of this 40 grams sugar and 60 grams water, if it is done say 5 times, so then it will be 90% raised to 5 into 40 grams, this would be the final amount of sugar in the water. If it is done 6 times, 10 times, whatever, you just change the index over here, you get the final amount of sugar in water. So always remember, initial concentration or quantity into V by T raised to N, where essentially V is equal to, sorry, this part I'll just write properly, V by T raised to N, where V is essentially the amount of part that is not touched divided by the total volume, or total amount of weight that is not touched divided by the total weight, that raised to N number of steps is equal to the final concentration or final quantity. So that is the thing that you have to remember when it comes to this particular type of problem. This will be better understood with the help of a problem. So let's take a look at the next question. Consider the question as shown. Rahul takes a solution which contains 100% pure water and replaces 40% of it with baking soda. He repeats this process 2 more times and stops. What is the ratio of soda to water in the final solution? So you have 100% pure water. So the initial concentration is how much? Initial concentration is 100%. If we find out the final concentration, we can find out the required ratio of soda to water as such. So each time you are removing water and you are adding back soda. So whatever percentage of water you are not removing out, that will be V. So if you are taking 100%, you are taking 40% out. V, that is the part that is left untouched, is 60%, and total volume T is equal to 100%. So each time 60% is remaining untouched and 40% is being replaced. So after, so he does one step and he does it 2 more times. So he does that step 3 times. So final concentration, this is equal to, N in this case is 3. So if I use the formula, this is 60 by 100 cube times initial concentration, which is 100%. So this is how much? This is 6.6 cube, so that is 21.6%. So 36% into 0.6, 21.6% is the final concentration of water. Initial concentration was 100%, the final concentration is 21.6% of water. Now if this is the concentration of water, how much is soda then? Out of 100%, if 21.6% is water, then soda will be the remaining 78.4% will be soda. So what is the ratio of soda to water? The ratio, required ratio essentially is, this required ratio would be 78.4 divided by 21.6. So this is 784 by 216 divided by say 8. So this would be 256.27 divided by 8. This is 9. 64.98. So this is the required ratio is 98 by 27, which is option A. So as you could see, it became much more quicker. We don't have to repeat the steps n number of times to find out the concentration. If I know that 60% is left untouched, after the first percent it would be 60%. Second step, it would be the final concentration of water would be 36%. After the third step, it would be 21.6% and so on. So if final concentration of water is 21.6%, then concentration of baking soda would be 1 minus that, which is 78.4%, and then we can easily get the required ratio. So this is basically how we can save time while solving questions based on replacement of solutions. Now let's take a look at the next topic, which is of time, speed and distance. So most of you would know the simple time, speed and distance formulae, that is speed is equal to distance upon time, or you can say that distance is equal to speed into time. This is the very basic fundamental formula of time, speed, distance, but in some cases it becomes very difficult to solve by using just this simple formula of time, speed and distance. So in such cases, basically we use something which is slightly more complicated and than just the simple formula, which is the concept of relative velocity. A lot of people are not very comfortable with this topic, but in certain cases relative velocity can help quite a bit. It can help you save time, it can help solve questions that seem unsolvable. So what is the concept of relative velocity? See, basically if you consider all speed is relative speed, because when we consider our speed, when we say that okay, this car is traveling like 100 kilometers per hour, it is traveling with respect to earth, it is traveling at 100 kilometers per hour, the ground. It is not traveling with respect to sun at 100 kilometers per hour. The reason why that is the case is because our earth is also rotating, it is spinning, it is revolving around the sun. So the earth itself or the ground itself has some amount of speed and velocity, it has a direction of movement. So all because of that, you can't say that the car is moving at 100 kilometers per hour with respect to the sun. So when you say speed, by default the normal speed is with respect to ground. Now this means that the default frame of reference for any kind of calculation on time, speed and distance is the ground. But at times it can be a slightly inconvenient frame of reference. If you consider its movement with respect to ground, it is a fairly convenient way of calculating. But if there are two objects that are moving, sometimes it is more convenient to consider from the frame of reference of one of the objects, so that instead of figuring out how these two objects are moving, you just consider the movement of one of these two objects. So in that case, basically what we do, suppose A and B are moving, okay, A is moving and B is moving. Now if there are two objects that are moving, it becomes easier to consider what would be the resulting velocity or speed if you consider from the frame of reference of one of these objects. So what do you say? You say that instead of considering the frame of reference of the ground, I'll assume that this is a car A and I'm sitting in the car. If you're sitting in the car, you don't think that you yourself are moving. From your perspective or from the frame of reference of A, you are stationary. Now obviously if the car A is actually moving, then you can see that when the car B is coming towards you, it is actually moving much faster than it is with respect to ground. It appears as if it is coming with great speed. That is because you are both are moving in opposite direction. It feels that it is coming at great speeds. So from your frame of reference, B appears to be coming faster because in your frame of reference you are stationary, but from frame of reference of ground you are not actually stationary. So in this case, when you have two objects moving together, what you do is you assume one of them is stationary, or you can say that I am a bug and I am standing on object A. So from my frame of reference, this car is stationary, and suppose this is speed of A, this is speed of B with respect to ground. So from my frame of reference while sitting on object A, I feel that B is in fact moving towards me with the speed of SA plus SB. That is, when you have two objects moving towards each other, you assume that one of the objects is stationary and the other object is moving with the combined speed of the two objects. Why is this done? This is done basically to solve for questions which ask for time. If you have questions where, okay, this distance there is like 100 kilometers between them, this person is going at 10 kilometers per hour, this person is going at 40 kilometers per hour. Instead of saying that, okay, in 10 kilometers this person will cover, in 1 hour this will cover 10 kilometers, this will cover 40, in 2 hours this is 20 and this is 80, instead of doing all of those things, you can say that if I sit in on object A from the frame of reference of A, I am stationary and B seems to be coming towards me at the speed of 10 plus 40, that is 50 kilometers per hour. Initially it is 100 kilometers away and seems to be coming towards me at 50 kilometers per hour. So it is going to take time of 2 hours to reach me. When is relative velocity done? Firstly, when you have two different moving objects, you convert one of them into a stationary object and assume that the speed of the other is impacted. In all of these cases, you are basically trying to calculate the time that is required, because essentially the time that is required to travel is irrespective of the frame of reference. So whether your frame of reference is ground or sitting on the car, the time it actually takes you to cross, that remains unchanged in all scenarios. So that is basically the reason why you can take a convenient frame of reference just to calculate how much time it will take for the other object to cross you or basically to meet up with you. So that is the whole frame of reference. When to use relative velocity? When there are multiple moving objects and when you have to calculate the time of meeting as such. Remember, when you assume one element to be stationary and you transfer the speed to the other element, you are consciously ignoring the amount or distance traveled by A. So if you are asked, okay, how much distance is actually traveled by A when they meet, then you have to not, you can't directly use the concept of relative velocity. In this case, you have to first use relative velocity to find out the time of meeting, and from the time of meeting back calculate how much distance A has traveled. So basically remember the concept of relative velocity. When two objects are moving towards each other, you add the velocity. So if A and B are moving towards each other, the speed of B with respect to A is SA plus SB. If two objects are moving in the same directions, for example, if A and B are moving in the same direction, then the suppose this is A and this is B. Then the speed of B with respect to A is SB minus SA. If they are moving in the same direction, the formula, the relative velocity of B with respect to A or with respect to the frame of A is the difference of velocities. If they are moving in opposite direction, you have to take the sum of velocities. So that is the basic thing that you have to remember. Using this modified velocity, find out the time of meeting. From the time of meeting, you can then back infer the actual place of meeting or the distance that is traveled. So that is the basic concept of relative velocity. Let's take a look at a question based on it. We will try as far as possible wherever we have to determine time and people are moving towards each other, there are two objects moving, to use relative velocity. Ronald and Bale run between point P and point Q, which are 8 kilometers apart. So there is this P and Q, and that is 8 kilometers apart. Bale starts at 9 AM from point P, so you have Bale over here at 9 AM from point P, reaches Q and returns to P, so goes from here and then comes back. Ronaldo starts at 9:30 AM from Q, so this is Ronaldo, and he starts at 9:30 AM. From Q reaches P and returns to Q. The speeds at which both run are constant such that Ronaldo's speed is 1.5 times the speed of Bale. So suppose if this speed is x kilometer per hour, this speed is 1.5 x kilometers per hour. Now you have, while returning to their starting points, they meet at a point which is exactly midway between P and Q. At what time do both of them meet for the first time? So in this case, basically what are we saying, that when they are returning, so Ronaldo goes to P, and once he comes back, somewhere over here midway between P and Q, he meets Bale, who is coming back from Q back to P. So when basically Bale covers 12 kilometers in some time, and Ronaldo covers the same 12 kilometers in half an hour less, because he started half an hour after Bale. So basically Bale covers this 12 kilometers, going 8 kilometers back, the 12 kilometers at say time t, so he goes by x kilometers per hour, so he covers it in time t, and Ronaldo is going to cover the same distance going at 1.5 x kilometers per hour in half an hour lesser time. So this minus half will give you the time taken by Bale as such. So if I try to solve this, how would I do that? So I can say that this is 12, I would say this is 12 times 1 by x minus 1 by 1.5 x is plus half an hour, because this time is half an hour lesser than the time taken by Bale. So this is equal to half. So this is 1.5 x. So difference basically would be that this is 0.5 x by 1.5 x square. So that is 1 upon 3 x, or rather I will take the x also out. So this is 1 minus 1.5. So now 1 by 3. So this is 1 by 3. 12 by 3x is equal to half. So I can say that this is 4, x is equal to 8. So x, that is the speed of Bale, is 8 kilometers per hour, which means the speed of Ronaldo is 12 kilometers per hour. So we get the idea of how what they are doing and what is their speed, respective speeds as such. So we are asked at what time do both of them meet for the first time. So we have to find out when do they meet for the first time. We know the time they meet for the second time, which is when midway between P and Q as such. So when do they meet for the first time? Here we can use the concept of relative velocity, because essentially that is when they are both moving towards each other. If x is 8 kilometers per hour, in the first half an hour when only Bale is running, how much distance is he going to cover? Half into 8 kilometers per hour, that is 4 kilometers. So of this, Bale is going to be here at 9:30, and at 9:30 AM both are essentially running towards each other. This guy at 8 kilometers per hour and this guy at 12 kilometers per hour. We can use relative velocity when we know that both are running. We shouldn't use it when one is stationary. We don't know that for the first half hour Ronaldo is stationary, so that's not when we should use the concept of relative velocity. Now since both are running towards each other, what is the relative velocity? That would be the sum of both of these two. So consider that Bale is stationary. The distance between them is 4 kilometers. Suppose only Ronaldo is moving. From the frame of reference of Bale, Ronaldo would be moving towards him, since both are moving in opposite direction, with the combined speed of 20 kilometers per hour, right? And the distance between them is 4 kilometers. This is at 9:30 AM. So how much time would it take? This is 1 by 5, that is 1/5 of an hour. 1/5 of an hour is essentially 12 minutes. So for their first meeting, it would take them 12 minutes after 9:30 a.m., which is 9:42 a.m. So this is the right answer, option D. So always remember, in what context should you think of relative velocity? When two people are moving. When only one is moving initially, you should not use the concept of relative velocity. When we have to find out points of meeting, we should not use the concept of relative velocity. Use the normal time speed distance equation then. When we know for sure that okay, this is the distance between them, they are moving towards each other, find the time of meeting, that is when we should basically use the concept of relative velocity. So now let's take a look at the next topic, which is of circular tracks. So circular tracks uses the concept of relative velocity quite a bit in solving questions on circular tracks. So you should, by this time, most of you would know the concept of circular tracks. That is basically, if you have a track on which people are running, people can either run clockwise or counterclockwise, and there will be 1, 2 or 3 runners as such. The point is that whenever you have to figure out the number of times somebody is meeting on a circular track, remember, if you have to consider when would 2 runners meet or 3 runners meet at the starting point, you have to basically consider the time, you have to say that TA is the time taken by A to complete one lap, TB is the time taken by B to complete one lap, and so on. The LCM of these times, TA, TB, etc. will give you the time at which all of them arrive at the starting point, which would be the first time that they meet at the starting point. But that is not necessarily the time they meet. The first time they meet is when somewhere around this track where they will meet for the first time. So how do you find out when they meet for the first time? This gives you the time taken to meet at the starting point for the first time. When they meet for the first time is basically, suppose in this case the speed of A is greater than speed of B. Now in that case, if A and B are running in the same direction, what is going to happen? Essentially A is going to go up ahead, and at some point of time he is going to gain enough distance on B such that he meets up on B from behind, which means that A is going to essentially meet up with B when he gains one entire lap with respect to B. So if speed of A is greater than speed of B, they are going to meet when the distance between them is greater than one lap. So you can think of it from perspective of relative velocity. In this case, because they are moving in the same circular direction, you assume that B is stationary and only A is moving. Now since they are moving in the same direction, the relative velocity with respect to B becomes SA minus SB. And when would they meet for the first time? They would meet for the first time when the distance covered is the length of one lap. So that's let's say L. So when do they meet for the first time? Time for the first meet would be L divided by SA minus SB. This is if they are moving in the same direction. Now suppose A is moving in the opposite direction. Here relative velocity changes to SA plus SB. So time taken for the meeting would be L divided by SA plus SB. So always remember, when you have just first meeting, use the concept of relative velocity. If you have the concept of first meeting at the starting point, you have to use the LCM concept. Now another thing that comes to mind is how to find out the number of meeting points, or rather where do they meet for the first time. So in this case, I'll just change this one second. So in this case, basically remember, when you have to figure out when do they meet for the first time, the number of meeting points. In this case, what you have to do is you have to consider the speeds as such, that is SA and SB. That concept also comes from relative velocity as such. So if you have to consider there are two people A and B moving on the track with speeds SA and SB. If they are, first thing that you have to do is convert SA by SB into the smallest fraction form. That is basically, you have to make sure that the fraction form is such that M by N, say, such that M and N are co-prime to each other. That is in the fraction in its lowest form as such. There are no common factors left. So for example, 4 by 9 would be the fraction in the lowest form. 8 by 18 would not be a fraction in the lowest form because they have a factor 2 which is still in common with one another. So you have to convert this SA by SB into the fraction in its lowest form. Now once you have done that, the number of meeting points, if you have, if the runners are moving in the same direction, the number of meeting points is same direction. The number of meeting points is given by modulus of M minus N. This is if they are moving in the same direction. So suppose if it is 4 by 9, the number of meeting points would be 5. If they are moving in opposite direction, the formula is take m by n and you say this is equal to modulus of m plus n. So that is 4 plus 9, that is 13. So in that case, if they are moving in opposite direction, the number of meeting points would be 13. Now see, basically if you just have the number of meeting points, you cannot deduce what is the speed of the people who are running, because essentially firstly m and n are in the lowest form. So it can be 4 by 9, it can be 8 by 18 or anything as such. So you can't really deduce from just this as such. Another thing is that it is modulus and it is m minus n. So it can be 4 plus 5, 4 minus 5. In this case 4 minus 5 will not make sense because the speed will become negative, but in other cases that is also possible. So you have to be very careful. If number of meeting points are given and the speed of one person is given, it generally is not possible to determine the speed of the other person. You have to use other concepts to figure that part out. Okay, so this is the number of in circular tracks, the number of meeting points. Firstly you have to take the ratio of speed, reduce it down to the lowest form, and once you have reduced it down to the lowest form, see if they are moving in same direction, it is modulus of m minus n. If they are moving in opposite direction, it is modulus of m plus n. So now with this basic concept, let's go back to our question. So let's take a look at the next question. So consider this one. A and B are running on a circular track in the same direction. A crosses B for the first time when B finishes the fifth round. If both start running in opposite direction from the same point with the same speeds, how many unique points will they meet on the circular track? So in this case, we are given that A crosses B for the first time when B finishes the fifth round. So what does that mean that A is crossing B? A crosses B for the first time means that A gains 1 lap over B. Now 1 lap over B basically means that A completes 6 laps when B finishes 5 laps. So A completes 6 laps and B finishes 5 laps. What can this tell about the speeds of SA and SB? So time taken for them to do this is the same. So time is basically distance by speed. So if the distance is 6 laps and 5 laps, the speed are also in the same ratio because speed is directly proportional to distance. If time is essentially the constant, then distance would be directly proportional to speed. So that would mean if this is 6 and this is 5, then SA by SB, this ratio has to be 6 by 5. Now why did I come to that? Because essentially distance, or rather this is the other way around, you have to say distance is directly proportional to speed. So if the time is constant, distance A by distance B will be equal to speed A by speed B. Distance covered in that given time is 6 laps, in this given time is 5 laps. So the ratio of their speeds would be 6:5. Now once we get the ratio of the speeds, finding the number of meeting points would be very simple. This is already in the lowest form. There is no 6 and 5 are co-prime to each other, so I don't need to actually reduce the fraction any further. Now using this, how do I find out the number of unique points that they will meet at? Using simply the formula. So the number of meeting points, this is equal to modulus of 6 plus 5 plus, because they are running in opposite direction. So this would mean this is equal to 11. So how many meeting points do they have? They have 11 meeting points. Pretty simple if you know the formula as such. Now let's go to the next topic, which is of clocks. So in clocks also, most of you would understand how to solve clocks question, but find them very time consuming. So in this case, I'll give you two formulas which help you in reduce the time that is required to answer the question quite a bit. So firstly, remember, when the time taken for a minute hand to say, suppose this is your clock phase, this is 12, 1, 2, 3, 6, 9, this is 4, 5, 7, 8, 10, 11. So for the minute hand to cover an angle like this, the entire angle is 360 degrees, which means that the angle between each two set of numbers is 360 by 12, that is 30 degrees. So how much time does a minute hand take to cover 30 degrees? So the minute hand covers 30 degrees in 5 minutes. So this means that in 1 minute, how much does it cover? In 1 minute, it covers 6 degrees. Similarly, the hour hand, how much time does it cover to cover 30 degrees? 30 degrees it does in 1 hour, because essentially every hour it moves ahead by one sector as such. So it does 30 degrees in 60 minutes. So the hour hand does 0.5 degrees in 1 minute. That is 30 degrees by 60, so that is half a degree in 1 minute. Which means that what is the relative velocity of the minute hand with respect to the hour hand? both are moving in clockwise direction, but per minute, the minute hand, speed of minute hand with respect to r hand, that is the relative velocity of minute hand with respect to r hand is the difference of this, since they are moving in the same direction, like circular tracks, they are moving in the same direction. So the relative velocity of minute hand with respect to r hand is 6 degrees minus 0.5 degrees, that is 5.5 degrees in 1 minute, which means that the minute hand gains 5.5 degrees with respect to the r hand every minute. So this is the first important formula that you should remember. So if you are asked, okay, in how much time it would require for the r's hands to interchange themselves, or by what time will they meet up, you have to just say that, okay, initial angle is this, final angle is this, that means the minute hand has to essentially gain this much distance with respect to the r hand. So in relative velocity terms, what is the distance covered? In relative velocity terms, what is the speed? It is 5.5 degrees per minute. Using this simple formula, you can find out how much time it should take the minute hand to cover the distance with the r hand. Now another concept that is often asked is that you are asked what is the angle between the r hand and the minute hand. There is a simple formula to actually do that, and it comes from this concept that I just did. So what is the, if you have it something like say exact 4 o'clock, what is the angle between the minute hand and the r hand in that case? So for every at 4 o'clock exactly at 0 minutes 4:00, the r hand would be basically, if your r time is h00, where h is the number of r's or so, then in this case the r hand angle made by the r hand with the minute hand is how much? That is 30 degrees per hour. So 30 degrees into h would be the angle between the r hand and the minute hand. Now this is at the time when it is exactly 4 o'clock or 3 o'clock, okay. So at exactly 3 o'clock, the distance between the r hand and the minute hand is 30 into 3, that is 90 degrees. At 4 o'clock it is 30 into 4, that is 120 degrees. Now what happens post 4 o'clock, as you go from 4 to 4:20 or 4:30 as such, every minute the minute hand is essentially closing that gap. So essentially in that case we get that the minute hand is coming closer and closer to the r hand. At what rate is it closing this gap as such? It is closing this gap as 5.5 degrees per minute. So if you are asked what is the gap between, or what is the angle between the r hand and the minute hand, there is a quick formula for that. That is basically 30h, that is the starting position of the r hand, minus 5.5 times minute. So basically if you are asked what is the angle between the r hand and the minute hand at say 4:20 p.m, then you would say 4 o'clock it would be 4 into h would be 120 minus 5.5 times this, so this would be 5.5, 11, 110. So this would be 120 degrees minus 110 degrees, so this would be 10 degrees. So just using this formula you can find out what is the angle between the r hand and the minute hand. Just remember the angle between the r hand and the minute hand is 30 times the r minus 5.5 times the minute hand. So this is basically how you quickly find out what is the angle between the r hand and the minute hand. Now let's take a look at a simple question based on this. Let's take a look at the next question. Between 3 p.m. and 4 p.m, at what time does the minute hand and the r hand make an angle of 40 degrees with each other? So in this it is between 3 p.m. and 4 p.m, so h is equal to 3 essentially. Now we have to find out what is m value such that the angle between them is 40 degrees. In fact, we can see immediately that there will be two times as such, because firstly because of the modulus in that formula, and secondly because if it is 3 o'clock as such, one time the angle would be basically when you are this is say 3, one time when the minute hand is behind by 40 degrees, and the second time when the minute hand is ahead by 40 degrees. So there will be two such positions. Now let us take a look at when would these two positions be. 30h minus 5.5 m is equal to 40. So in this case 90 minus 5.5 m is equal to 40. So you have two cases, 90 minus 5.5 m is equal to minus 40, or 90 minus 5.5 m is equal to plus 40. So in this case I get that 5.5 m is equal to 130 degrees, 130, so m is equal to 130 by 5.5. So this is equal to how much? This is 130 into 5 divided by 1.1, this is 26. So this is 260 by 11, 260 by 11 is how much? This is equal to 2, 4, so that is 3, 23.7, 7 would be 6, and 23.6 something, 23 point, so in this case this 0.6 part essentially because you have to convert it into seconds as such, so it will be 23 minutes and how many seconds? So 23 would be 77 by 11 seconds, 7 by 11 seconds, so that is 7 into 60 by 11, so 420 by 11 seconds. 420 by 11 seconds would be 33, so 42 minus 33, 90, 38 seconds. So this would be at 23 minutes 38 seconds, which is there over here, which is option B. Because more than one of the above is also an option, I will also check this part, which if it leads me to a valid answer, then I will get actually 2 answers as such. So this would mean that 5.5 m is equal to 50. So m is equal to, so this would be 100 by 11. So this would be 9.09 something. So this part would be 9 by 1 by 11, so 60 by 11 seconds would be 5 seconds. So basically 9 minutes 5 seconds as such. None of the other 2 options are at 9 minutes 5 seconds. So only one option is valid, which is option B. So as you could see, once I had this formula, solving this became very trivially easy. So remember this formula, this is modulus of 30h minus 5.5m. Now let's go back to our topic. Now we'll go over to area of triangle. So we have covered quite a few concepts till now. So we are starting with some amount of geometry concepts. In this side, geometry has a lot of formulae. I won't be covering all of them, but I'll basically be covering those formulae which people tend to forget or tend to overlook in their preparation. I want to make sure that if there is any kind of concept that is generally overlooked, that I highlight that to you so that you don't overlook that concept, because it does come in CAT. A lot of times people know that the area of a triangle, they know the simple formula for area of triangle, which is half into base into height. But there are multiple formulas for area of triangle. This is the simplest one. Then there is the Heron's formula. Heron's formula is what? Heron's formula, area is equal to S into S minus A into S minus B into S minus C. Here A, B, C are sides of the triangle and S is the semi-perimeter. Semi-perimeter basically means that this is the sum perimeter by 2. A plus B plus C by 2. So in this case, basically if you have the 3 sides of the triangle, you have ABC, then you can use this formula. Using ABC, you calculate S, and then after you have S and ABC, you can calculate the area of the triangle. So if you have the 3 sides of the triangle, you can calculate the area of the triangle. Now suppose you don't have 3 sides, suppose you have 2 sides and the angle included. Then also you can calculate the angle, area of the triangle. In that case, area is equal to half AB sine C. So suppose you have length of one side, length of other side, and you have the angle C between them, then area of the triangle is equal to half AB sine C. This is very important to remember, especially whenever you see any kind of triangles question. If it is given, assume sine of 40 degrees is equal to this much. That should directly tip you off that you have to use this formula as such. Okay. Now another formula that is useful is basically that involving circumradius and inradius. These generally don't come directly. So essentially what happens is that you will be given the area of the triangle and you have to calculate the circumradius using this particular formula, or you will be given the area of the triangle, or it is determinable what is the area of the triangle, and you have to calculate the inradius. So the two formulas are area is equal to ABC by 4R. Now if you have the lengths of the sides ABC, what you can do is by using the lengths of the side you can calculate A using Heron's formula, and then by using this formula you can calculate capital R, which is the circumradius. So this formula is less used for calculating area, and it is more often used to calculate the circumradius as such. But this is also an important area formula. This is an area formula to calculate the area using the circumradius. Now another formula, area formula is there, which uses the inradius, which is R into S. Here R is the inradius and S is our semi-perimeter. Now again, if you have the length of 3 sides and you have to calculate the In radius, you use calculate semi-perimeter, you calculate area using the Heron's formula, and then using A by S, you can calculate what is the in radius. So this is the basic thing that you should remember when it comes to area of triangle. Another thing which many people tend to forget when it comes to area of triangles, etc., is the special values that you have to remember when it comes to area of triangles like equilateral triangles. Always remember area of an equilateral triangle of side A. Suppose the side of the equilateral triangle is A. This is equal to root 3 by 4 A square. What is the circumradius of an equilateral triangle? The circumradius of an equilateral triangle is A by root 3. And what is the inradius of an equilateral triangle? That is small r is equal to A by 2 root 3. Only in the case of a equilateral triangle is r equal to 2r. Okay, so always remember capital A for an equilateral triangle, this is equal to root 3 by 4 A square. Circumradius is A by root 3 and in radius is A by 2 root 3. In many triangles questions you are given equilateral triangles, so knowing these formulae by heart can reduce quite a bit the time taken to actually solve these kind of questions. Another thing you have to remember is that in an equilateral triangle, the altitude and the median are coincident, they are the same thing. So whether it is altitude or whether it is median or angle bisector, all are the same lines as such. So if this is AD and this is an equilateral triangle ABC, the median is also the altitude and is also the it would also be the whatever you say, angle bisector. So the in center, centroid, circumcenter, all are essentially coincident in that case. Okay. Another thing that you have to remember when it comes to a triangle is that the centroid divides the triangle in the ratio 2:1. So if this is the ABC, this is the median D, then and suppose BE is the other median, then in this case the centroid G is over here, then AG is to GD, this is equal to 2:1. So a lot of formulae that you have to remember in geometry, I am nowhere covering all the formulae that you have, but these are important aspects of triangles that you should that are must know as such. So with that we will go to a simple question on area of triangle which uses the alternative areas of triangles. So let us take a look at the next question. A triangle is formed by the line x plus y is equal to 4 and coordinate axis. What is the ratio of inradius to circumradius for the given triangle? So you have the coordinate axis and you have the line x plus y is equal to 4. So this is essentially 0, 4 and this is 4, 0. So what is the area of this triangle? This is a right angle triangle because the coordinate axes are perpendicular to each other. So in this case, what is the area of the triangle? This is base, say this is height, this is base. So area is equal to half base into height. So this is equal to half into 4 into 4. So that is equal to 8 square units. Now using this, what would be we have to find out inradius and circumradius. So for inradius, I know that A is equal to RS. What is the semi-perimeter over here? This is 4, this is 4. By Pythagoras theorem, if I use Pythagoras theorem on this triangle, suppose this triangle is ABC, by Pythagoras theorem, this would be 4 root 2. So what are the sides of the triangle? That is 4, 4 and 4 root 2. So semi-perimeter is how much? Essentially this would be 8 plus 4 root 2 divided by 2. So this is 4 plus 2 root 2. Now I have semi-perimeter also. So using that, can I find out the inradius? Inradius would be 8 divided by 4 plus 2 root 2. So if I cancel out, so this is 4 plus 2 plus root 2. This is the inradius. Can I also use the area formula to calculate the circumradius? So by area formula, R is equal to ABC by 4A. So this is equal to how much? This is 4 into 4, 16 into 4 root 2. So that is 64 root 2 divided by 4 times A, which is 8. So this is 32. So this is 2 root 2. So R, capital R is 2 root 2. So we have to find out the ratio of inradius to circumradius. So that is the ratio of 4 to this. So I would say R by R is equal to 4 divided by 2 root 2 into 2 plus root 2. If I cancel off this root 2 with 2 over here, I get this is root 2 divided by 2 plus root 2. So this is equal to option C, which is root 2 divided by 2 plus root 2. So this answer over here gives us that R by R is root 2 divided by 2 plus root 2, which is option C. As you can see, this is a pretty simple question. We just had to be careful of getting the ratio of inradius to circumradius. Now let's get back to our next concept, which is of triangle theorems. Now most of you would know the proportionality theorem, etc., and there are many triangle theorems would be aware of. One of the few of the triangle theorems that people forget are the Apollonius theorem and the angle bisector theorem. So let us try to review those. First is the Apollonius theorem. So what does Apollonius theorem say? So according to Apollonius theorem, if AD is the median of the triangle ABC, then 2 times AD square plus BD square, this is equal to AB square plus AC square. This is something whenever you get in a triangle, if a median is given and the squares or sum of squares are asked of the sides, you should immediately think of Apollonius theorem. So the sum of the squares of the other two sides is equal to 2 times AD square plus BD square. Okay. The other theorem that you should remember when it, which essentially comes, which is derived from Apollonius theorem, is basically the property that 3 times the sum of squares of the sides. So suppose this is AD, this is BE is the other median, and CF is the third median as such. So 3 times the sum of the squares of the sides of the triangle, that is AB square plus BC square plus AC square. This is equal to 4 times the sum of the squares of the median. So this is 4 times AD square plus BE square plus CF square. This comes basically from Apollonius theorem. So if you convert it this way, see 2 times BD square, if you take AB square plus AC square and you do it 3 times as such, you will have that AD square, 2 times AD square plus 2 times BD square, but 2 times BD square is essentially half of BC square. So from that you get this property. If you just add up all the equations that are possible when it comes to medians, you get this equality, that is 3 times the sum of squares of the medians, you get this is equal to 3 times the sum of the squares of the sides is equal to 4 times the sum of the squares of the medians. 3 times, remember, 3 times sides would be equal to 4 times sum of square of medians. So medians is the shorter sum or the lesser sum, sides is the greater sum. Okay. So these are the 2 important properties that you should remember whenever sum of squares of sides comes, sum of squares of medians comes. You should remember these 2 properties immediately. Now let us take a look at a quick example based on this. So let's see the next question. In a triangle PQR, 2 medians are perpendicular to each other. If the sum of the squares of the length of these 2 medians is 81 centimeter squares, then find out the length of the third median of the triangle PQR. So here we are given sum of squares of 2 medians. So immediately you should think of the Apollonius theorem and the property that we just discussed. So in this case, consider the triangles. So here you have, this is 90 degrees as such. Okay. So suppose another thing that you remember that I said that the point of intersection of medians is the centroid. So this is G, say this is A, B, C, this is G, which means that this AG to A, this is say D, this is E. So AG to, so we have to find out essentially the length CF. So consider we are given AD square plus BE square, we are given as 81 centimeter square. Now here G is the centroid, which is the point of intersection of the medians. So we know that AG to GD is 2:1 because the centroid divides every median in the ratio 2:1. So in this case, assume that AD is 3x, so this will be 2x and this will be x. Assume BE is 3y, so this will be 2y and this will be y. So using the theorem, I got at least the length of each of these parts as such. Now if I consider this is a right angle triangle, so what can I say about BD square? BD square, this is equal to, these are the right angle triangles and BD is a hypotenuse. So that will be 2y the whole square plus x square. So this is equal to 4y square plus x square. But what is BC? BC is nothing other than 2 times BD. So BC square would be equal to 2 times BD square, BD the whole square. So that is 4 BD square. So 4 times BD square, this will be equal to 4 times this, so that is 16y square plus 4x square. So BC square in terms of x and y is 16y square plus 4x square. I'm just trying to calculate the sum squares of each of the sides so that I can use the property 4 times the sum of square of the medians is 3 times the sum of square of sides. So if I can express the sum of square of medians in this format, x square plus y square, and the sides in the same format, then I can find out the length of the missing median as such. So if BC square is this, what is AE square? In this case, this is also 90 degrees. All of these individual angles are 90 because they are essentially intersecting at 90 degrees. Now this is 2x, this is 2y, and A is the hypotenuse. So again, AE square is equal to how much? AE square is equal to 4x square plus y square. Again, AE is equal to half of AC. So AC square is 4 times AE square. So that is essentially 16x square plus y square. Now I found BC square, I found AC square. I have to find out AB square as such. But this is also 90 degrees and this is 2x, this is 2y. So what is AB square? AB square is nothing other than 2x the whole square plus 2y the whole square. So this is equal to 4x square plus 4y square. So what is the sum of the sides as such? Sum of the sides basically that would be equal to how much? That would be equal to, sum of the sides would be equal to how much? I found this is 16x square, 16y square plus 4x square. This is AC square is 16x square plus y square. So 3 times AB square plus BC square plus AC square is how much? This is equal to how much? This is 3 times 4x square plus 4y square plus 16y square plus 4x square plus 16x square plus 4, this is 4 times because this is 4 times this, so this would be 4y square. So if I consider this, this is 3 times 24x square plus 24y square. Okay, but what is actually given? We have to find out the sum of the squares of the lengths of the two medians is 91 centimeter square. So how much is that? That is essentially this is 3x, essentially 3x the whole square plus 3y the whole square is equal to 81. So 9x square plus 9y square is equal to 81, or rather x square plus y square is equal to 9. Now x square plus y square is equal to 9, so 72 times x square plus y square is there. So that is 72 times 9, so that is equal to how much? This is 630 plus 18, 648. So we get that the 3 times of sum of the squares of the sides is 648. Now this should be equated with 4 times the sum of the squares of the medians. So if you get, this is the sum of 648. 648 is 4 times the sum of the squares of the median. So this is equal to how much? 648 is sum of the squares of the medians. Of the other two medians is 81 anyway. So 81 plus our missing median. So let's say our missing median CF is of length m. So this is plus m square. So 81 square plus m square times 4 times this is equal to 648. So how much is this? 81 square plus m square is equal to, divided by 4, this is 162. So 162, so that means m square is equal to how much? This is equal to 81. So m is not, it can't be minus 9 because it is the length of the median. So m has to be equal to 9 centimeter. So what is the length of the median as such? What is the length of the third median of the triangle PQR? It is 9 centimeter, which is option D. So as you could see in this particular question, we heavily relied on this property, 3 times the sum of the squares of the sides is equal to 4 times the sum of the squares of the median. In general, whenever you see the sum of the squares of median, immediately you should think of this property and Apollonius theorem. Now let's go back to another property a lot of people forget, which is, or rather a theorem which a lot of people forget, which is the angle bisector theorem. So let's take a look at the angle bisector theorem once. So in the angle bisector theorem, we have a, there are two theorems that are possible. Suppose you have a triangle ABC. According to angle bisector theorem, suppose AD is the angle bisector of angle A. So this means this angle is equal to this angle. Then according to internal angle bisector theorem, AB by AC would be equal to DB by DC. That is, the ratio of these two sides, AB and AC, D would divide the other third side in the same ratio in an angle bisector. So AB by AC, the ratio of the other two sides would be also the ratio in which the point D divides the third side. So this will be equal to dB by dC. The external angle bisector theorem is identical. There is no real difference as such. Here you just have to, instead of bisecting the interior angle, you have to bisect the exterior angle. So suppose this is ABC, this is your angle A. So if you extend it out, you get the exterior angle A, which is essentially 180 minus this angle A as such. If you bisect this angle, exterior angle A, you get the external angle bisector, which is say D dash, okay. A D dash is the external angle bisector such that this angle is equal to this angle. Now according to external angle bisector theorem, this external angle also divides the third segment, extended third segment, in the same ratio as AB by AC. That is, AB by AC is equal to D dash B by D dash C. So as you can see, nothing really changes between the internal and external angle theorem as such. Only you have to consider, is it internal, then it is dB by dC. If it is external, it is D dash B by D dash C. You have to consider the full distance from here to here, okay, which also contains DC as such. Many people make the distance of making it like BC by DC, which is incorrect. You have to consider from D dash, external point, to B, and external point to C. So this would be the longer distance, this would be the shorter distance as such. So always remember that in external angle theorem, AB by AC will be equal to this. So that will be equal to D dash B by D dash C. Now let's take a look at a simple question on angle bisector theorem. Now that you've just learned this should be easy for you to do. So consider the following question on angle bisector theorem. In a triangle MNQ, Mn is equal to 14, NQ is equal to 8, MP is equal to 7. Okay, P is a point on MQ. Okay, so we have to say this is MNQ. So this is Mn, which is 14, this is 8, NQ is 8, and MP is 7 centimeter. P is a point on MQ such that NP bisects the angle MNQ. So this is the angle bisector of this angle, and this is MP. MP is 7 centimeters as such. This angle is bisected by NP. Find PQ. So we have to find out this length as such. Now we can simply use our angle bisector theorem. So NP is the angle bisector. So by angle bisector theorem, NQ by NM is equal to PQ by PM. If you find it difficult to remember the formula, just remember the other vertex to one of the other vertices. So NQ by NM is the same, this ratio is equal to P, that is the point at which the angle bisector touches, to PQ by PM. So according to this, NQ by NM is equal to PQ by PM. We have to find PQ. So essentially PQ is equal to NQ into PM by NM. How much is NM? NM is essentially Mn, which is given as 14. How much is NQ? NQ is 8. How much is MP or PM, which is 7. So this is equal to 2, this is 1, this is 4. So PQ is equal to 4 centimeters. So what is the right answer? Then find PQ. PQ is option D, 4 centimeters. Very simple application of the internal angle bisector theorem. If you know the theorem, it becomes very easy to remember. Whenever you are given an angle bisector, think of this theorem. Now let's get back to our concepts. So I'll be covering some of the important circles concept. I'm not covering all the circle formula. I'm just covering those that you absolutely need to know and people tend to forget as such. So the first thing that you have to remember is the tangent secant formula. So a tangent secant formula basically means that if you draw a tangent from an external point, say, so consider an external point A, and from there you drop a tangent to a circle. So suppose this is the tangent at T, so this is AT, this is the tangent to the circle, and if you draw a secant from point A, secant basically means that it cuts through 2 points on the circle and forms a chord. So suppose this is A, C and D, okay. So according to tangent secant formula, AT square, that is the square of the length of the tangent, this is equal to AC into AD. So whenever you see a secant, whenever you are required to find out the length of any part of the secant, generally you will be asked the length of the chord, okay, and the length of the tangent is given. Always remember AT square is equal to AC into AD. So you have to consider not just AC into CD, but you have to consider from this external point to point C, into from this external point to the further point D. So you have to consider this will be like, say if it is 3 and 6, this will be 3 into not 6 but 3 into 9. You have to be very careful. A to C into A to D. So A to D will be 6 plus 3, which is 9. Always be very careful of that particular aspect. Many people make this mistake where they consider it as 6 into 3 and then they get the wrong answer. Now let's take a look at a simple question from this. So consider the next question. In the given figure, tangent RQ is equal to 20 centimeter, NQ is 16 centimeters, then what is NP? So according to our formula, RQ square, that is the tangent square, is equal to Q times N into Q times P. I always raise from external point to nearer point, external point to farther point. So that makes you very conscious of the fact that you have to consider the full length. So RQ square is how much? This is 20 square is equal to Qn, so that is 16 into Qp. So this is Qp is equal to how much? That is 400 by 16. So this is equal to 400 by 4, that is 25. So Qp is 25. So if Qp is 25, what is Np? Np is essentially Qp minus Nq. So that is 25 minus 16. So this is equal to 9 centimeters. So the length NP is equal to 9 centimeter, which is option C. So always be careful of what is asked. Make sure that you get the right length and then mark the answer. Now let's take a look at another concept from circles, which is the alternate segment theorem. A lot of people forget this simple formula, simple theorem, which helps a lot in many of the questions that are there. If you don't remember this theorem, it becomes very difficult to solve many questions that come in circles. So whenever you see an angle that is required or an angle is given and a tangent is there in that circle diagram, then you have to think of alternate segment theorem. So according to alternate segment theorem, so if you have a tangent like this, say tangent at point T, or rather consider a tangent at point C, and CD is a chord. Okay, so if you think there is a chord intersecting a tangent, at the same point there is a chord, the same point there is a tangent, immediately think this requires the alternate segment theorem. According to alternate segment theorem, this angle made by the chord with the tangent x degrees, this is the same angle that is subtended by the chord in the alternate segment. So this is equal to x, this would also be equal to x degrees. Alternate segment, why? There are two segments to a circle. If you consider a chord CD, there will be a major segment, minor segment. So wherever that angle is made, the angle that is subtended is in the other segment, other part of the circle. So if this is x degrees, then this is made in the minor segment, so the angle subtended in the major segment. If this is y degrees, this is the angle made in this particular segment, so it is the angle subtended over here. This will be y degrees. So always remember this basic concept of external alternate segment theorem, where the angle made by the chord and the tangent is equal to the angle subtended by that chord in the alternate segment. So if the angle is made over here, then it is subtended in the alternate segment over here. If the angle is made over here, it is subtended in the alternate segment over here. So always remember this particular concept. Now let's take a look at a simple question based on this. So consider the following question. This is not a simple question at all. If you don't know the concept of alternate segment theorem, this becomes very difficult to solve. Then you'll have to actually draw out many parts to figure out what is the answer. But with the alternate segment theorem, it becomes much easier. So let's take a look at the question. The chord AB is extended to the point P such that PC is tangent to the circle with center O. What is the value of angle AOB in degrees? X. So we have to find out this X. If we find out this value, this angle as such, this will be 2 times x will be 2 times ACB. So let us try to find out that angle as such. See, if this is 30 degrees, CB is the chord, CP is the tangent, then according to alternate segment theorem, what is this angle? This angle will also be 30 degrees. Now if this angle is 30, this angle is 40, then what is angle ACP? In triangle ACP as such, you have this is 30, this is 40. So angle ACP plus 30 degrees plus 40 degrees will be equal to 180 degrees, all the interior angles of the triangle as such. So we get angle ACP is how much? This angle is equal to 100 and this is 180 minus 70, so that is 110 degrees. So if this is 30 degrees, so what is this angle? This angle becomes 80 degrees. So angle ACB is 110 minus 30, that is 80 degrees. Now what is angle AOB then? AOB is basically 2 times angle ACB. because angle subtended at the circumference is half the angle subtended at the center. So angle AOB is 2 times angle ACB, so that is 2 times 80, so that is 160 degrees. So what is angle AOB? Angle AOB in degrees is 160 degrees, that is option C. This became very easy to solve because we could immediately identify this angle to be equal to 30 degrees using the alternate segment theorem. Okay, now let's take a look at the next concept which a lot of people forget, that is the formulae for length of common tangents. See, the point is that if you get a question on length of common tangent, if you remember the formula, solving it can be done in under 1 minute, but if you don't remember the formula, it will take 3 minutes or so, which is a waste of your time. So try to remember the formula for the lengths of the common tangents. There are 2 common tangents given any circle. So there are the direct common tangents which you can draw like this. They will be of equal length, and then there will be the transverse common tangents which you can draw cross like this. Okay. The length of the direct common tangent, suppose the distance between the 2 circles is D, and this circle is say R1, which is the bigger circle, and this circle is say R2, then the distance or the length of the direct common tangent is given by, this is equal to square root of D square minus R1 minus R2 the whole square. And for the transverse common tangent, this length is equal to D square minus R1 plus R2 the whole square. Now if you take a look at the 2 formulas, you will see since this is minus R1 plus R2 the whole square, this value would be lower than the length of the DCT. So length of transverse common tangent is less than the length of direct common tangent, because here you are subtracting the sum of the 2 radii, here you are subtracting the difference of the 2 radii. So if you find it difficult which one is which, just remember that the length of the transverse common tangent is smaller. By default it is always smaller than the length of the direct common tangent. This tangent would be longer. This tangent which you are drawing cross is the shorter tangent. So when you remember that, you will remember that this is R1 plus R2 and this has to be R1 minus R2 then. In case you are wondering how this actually comes about, the formula derivation is pretty simple actually. This comes from the fact that this is 90 degrees, this is 90 degrees. So if I draw a line parallel over here, like if this is 90, this is also 90 because it's a parallel line. What is this length over here? This is R2, this is R2, this is a rectangle. So this becomes R1 minus R2. D is the hypotenuse of this right angle triangle, which is essentially the hypotenuse is D. This one side is R1 minus R2, and this length is essentially the parallel side of the other side of the rectangle. The length of the direct common tangent is one side of the rectangle and the other side is this side of the right angle triangle. So by Pythagoras theorem we get the length of this side. This side is equal to the length of the tangent. So from there we get D square minus R1 minus R2 the whole square. So this is just basically from Pythagoras theorem. Similarly, you can use the same concept to figure out the length of the transverse common tangent also. But in an actual CAT scenario, figuring out the formula is almost impossible. You will not be able to solve it in time. So try to remember this formula: length of direct common tangent, length of transverse common tangent. So let's take a look at a question based on this topic. So consider the following question. 2 circles are shown of radius 5 centimeters, AB and CD are tangents to them. If AB is 26 centimeters, what is the length of CD? So we are given the length of the direct common tangent, which is 26 centimeter. Also remember, the length of direct common tangent will be, both direct common tangent will be equal in length, both transverse common tangent will be equal in length. So from that point of perspective, let us try to figure out the answer to this. So the length of the direct common tangent is given as this R1n is equal to R2 is equal to 5 centimeter. So let us try to use the formula. Length of DCT is how much? This is square root of D square minus R1 minus R2 the whole square. So R1 and R2 are equal, so this becomes 0. So D essentially this becomes DCT is equal to square root of D square, which is essentially equal to D. So the length of the direct common tangent is equal to D. In general, if you have circles of the same size as such, the distance between the circles will be equal to the length of the direct common tangent, because essentially if you draw a, this is 90, this is 90, this is 5, this is 5. So this side will also be parallel. So the distance between the center will be equal to the distance or the length of the direct common tangent. Now I know D, I know R1 and R2. Can I find out the length of the transverse common tangent using the same formula? So length of transverse common tangent is equal to square root of D square minus R1 plus R2 the whole square. This is square root of 26 square minus 5 plus 5, so 10 square. So this is basically square root of, we know that 5, 12 and 13 are a Pythagorean pair. So in this case we have 10 and 26, which means that the third part of the Pythagorean pair would be basically 24. So this will give us 24. Even if you don't remember the Pythagorean triplet, you should just calculate over here. This would be 26 square will be 169 into 4, so 640 plus, so this is 676 minus 100, so you get 576, square root is 24. So try to remember Pythagorean triplets as much as possible. Even if you don't remember, you can calculate, but then you just end up losing a little bit of time. So in this case we get, what is the length of CD? We get length is 24 centimeters. Let's go back to our concepts. Let's take a look at the next formula that most people forget, which is of distance between points. So in this case we have to figure out what is the distance between 2 points. This is the basics of coordinate geometry. If you are given 2 points x1, y1 and another point x2, y2, the distance between x1, y1 and x2, y2 d is equal to the square root of x1 minus x2 the whole square minus y1 minus y2 the whole square. So if you are asked to find out the distance between any 2 points, this is a formula that you need to know. Basically, how does it come about? If you draw a right angle triangle like this, one side of the right angle triangle, because this is parallel to the x axis, this is parallel to the y axis, this length will be basically y2 minus y1, and this length of side of the triangle, right angle triangle would be x2 minus x1. So the sum of the squares would be equal to the length of the hypotenuse, which is the distance between the points. So this is basically the formula that you should remember for distance between any 2 points. Now suppose you are given a pair of parallel lines and you are asked for the distance between them. So how do you find out the distance between them? You can try to figure out 2 points on them and then find out the line this between them. But if you have to then find out the points which will lie on the same line, then you can say that is the distance between them. And that line has to be perpendicular to both. That way you can find out what is the distance between the parallel lines. But there is a quick shortcut formula to actually finding out the length of distance between 2 parallel lines, which is basically given by this particular shortcut formula. So suppose what is the equation of parallel lines? So for 2 lines to be parallel to each other, their slopes have to be equal. So essentially if you consider a1x plus b1y plus c equal to 0, c1 equal to 0, and a2x plus b2y plus c2 equal to 0. If their slopes are equal, then a1 by a2 will be equal to b1 by b2. That is the check we need to make for to see whether the slopes are equal. Now if c1 is equal to c2, what would it mean? If c1 is equal to c2, then they are not parallel lines, they are coincident line, it's the same line. But if c1 is not equal to c2, that means that they are parallel lines. They are intersecting the y-axis at 2 different intercepts. So that would mean that they are not the coincident line, but they are parallel lines. So if you know that a pair of 2 lines is like this, a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then we get the distance between the 2 pairs of parallel lines as modulus of c1 minus c2 divided by square root of a square plus b square. This gives you the distance between the 2 parallel lines. That is the difference between the constants in their equation divided by square root of a square plus b square. If you remember this formula, you can quickly identify the distance between parallel lines. Now let us take a look at a simple question based on this.
Google search Quant Formulas PDF. Click on the first link. You will get a list of topics for CAT. Click on one of the topics. Download the PDF to get a list of formulas for the topic.
So consider the following question. One of the diameters of the circle x square plus y square minus 2x plus minus 6y plus 6 is equal to 0 is a chord of the circle with center 2, 1. What is the radius of the circle with center 2, 1? So firstly, let me convert this into a equation for the circle, so I can identify what is the radius of the circle, what is the center of the circle. So x square plus y square. So I'll instead of doing that, instead of this, I'll say x square minus 2x plus 1. I'm just trying to form perfect square, plus y square minus 6y plus 9. This is a perfect square, this is a perfect square, this is plus 10. But we have only plus 6, so I have to do minus 4 is equal to 0. So this would mean x minus 1 the whole square plus y minus 3 the whole square is equal to, taking 4 the other side, 2 square. So if I compare this with the equation of a circle, the general equation of a circle is x minus h the whole square plus y minus k the whole square is equal to r square. H and k are the x and y coordinates of the center of the circle, r is the radius. I know that this circle is, the center of the circle O is at 1, 3 and the radius of the circle is equal to 2 units. Now I found out the circle as such, the radius of the circle is 2 units, its center is at 1, 3, and I know that the chord with the circle center 2, 1, this one of the diameters of this circle is a chord of a circle with center 2, 1. So let us consider this circle is at 2, 1 and one of the chords of the circle is a diameter of this circle. What if this is the radius, what is the length of the diameter of this circle? This would be 4 units as such. So this is 4 units, which is the diameter of the circle, and the diameter of the circle has to pass through O as such. So this is O over here, this is 2 units, this is 2 units, and this is O over here, which is the diameter of this other circle, which is at 1, 3. Now this is a chord of this circle with the center 2, 1. Now knowing this, this is 4, this is 2, 1. What can I say about the radius of this other circle as such? Suppose this is r. Then I can say from this that if I join the midpoint of this chord, this will be a right angle triangle, which means that if I find out the distance between O and this center of the other circle, see, that plus 2 square will give me the length of the other circle as such. So according to, firstly, what is the distance between the two centers? The distance between the two centers d, say this is d, this is equal to square root of 2 minus 1, that is 1 square, plus 1 minus 3, that is minus 2 the whole square, so 2 square. So this is equal to root 5, this d is equal to root 5. So this is 2, this is root 5, and this is a right angle triangle. So what is r? R square is equal to root 5 square by Pythagoras theorem plus 2 square. So that is 5 plus 4, that is 9. So r is equal to root 9, so that is 3. So what is the radius of the circle with center at 2, 1? It is equal to 3 units. So the right answer is option A. As you could see in this case, we basically had to realize that this was a diameter is a chord of the circle. You draw it and just use the distance formula to find out this length. And this is 2 units because it's a diameter, so, and it is the midpoint. So this is a right angle triangle. Using Pythagoras theorem, it became easy after that. So as you can see, many of these basic concepts are fundamental to solving most of these questions, which involve many of the mixed concepts of geometry. So now that you know most of these concepts, let's take a look at some of the other concepts from quant section. So let us take a look at the following question. In this question, we will also apply the concept of distance between the two lines. So let's take a look at the question first. Two lines, 14x minus 33y plus 15 is equal to 0 and 28x minus 66y plus 52 equal to 0 are tangents to the same circle. If the center of the circle is in the second quadrant, find the radius of the circle. So in this case, basically you have two possibilities. In case the lines are parallel to each other, then you have the case where the circle is there and these two parallel lines are there, and since the lines are tangent to it, the diameter of the circle will be equal to the distance between the two parallel lines. On the other hand, if these are intersecting lines, then you have a scenario like this, and from this you will have to find out the radius of the circle. So let us first see which is the case, are these parallel lines or non-parallel lines. Now in this case, if the lines a1 by a2, if they are of the form a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 is equal to 0, in this case you have to basically see if a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. What happens if it is equal to C1 by C2? Then it becomes the same line. So it's like the same line as such, coincident line. So it is not a group of parallel lines as such. So let us see what is the case. If A1 by A2 is not equal to B1 by B2, then they are intersecting lines. If A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, then they are parallel lines. So in this case you have 14 by 28 is equal to minus 33 by minus 66. So this is half, this is half. So A1 by A2 is equal to B1 by B2. Is it equal to C1 by C2? So that is equal to 15 by 52. So this is not equal to half. So they are a group of parallel lines. We can say that the radius of the circle can be determined by finding the distance between the lines. If you find the distance between the lines, that would be equal to the diameter of the circle as such. So now we can use a formula for distance between parallel lines. If you remember, the distance d formula was basically C1 minus C2 divided by square root of a square plus b square. But what is a square and b square over here? In this case, what you have to basically do is convert both of these lines into the same format. That is, in this case, this is 14 minus 33 plus 15, right? So even this you have to convert into 14 minus 33 because they have to be in the same proportion as such. If A1 and the A value for both and the B value for both should be equal, and C has to be adjusted accordingly. So if I divide this by 2, what do I get? I get 14x minus 33y plus 26 equal to 0. So I get that A is equal to 14 and B is equal to minus 33. This is when we can use this formula. Here then C1 is equal to plus 15 and C2 is equal to 26. You can't directly use this is plus 52 over here because essentially this is the same equation of the line multiplied by 2. So the equation, the line doesn't change if you multiply by 2, 3 or whatever. So you have to actually reduce it to the lowest form. And then use, so that if this is 14 and minus 33, this should also be 14 and minus 33 as such. So in that case, this is 14, this is minus 33, this is 15 and this is 26. So this is 26 minus 15, modulus of that, square root of minus 33 square plus 14 square. So how much is this? This would be equal to 11 divided by 33 square is 33 into 33, this is equal to 99 plus 99, 1089, square root of 1089 plus 196. So if I add 196 to this, I get 1275. Square root of 1275 would be how much? 330, 40. So somewhere between 30 and 40. What is 35 square? 35 square is 5175 plus 105. So this is 5. So this is 1225, not 1275. Okay. So this would be very close to 35 as such, but actually we don't need to do that because this is given in the required format. So this is 19, this is 1985, that's why it's 1985. So this is essentially equal to 11 divided by square root of 1285. So this is what? This is D. Now our required value, we are asked what is the radius of the circle. So the radius of the circle, this is the diameter of the circle, the radius would be half the diameter, that is basically 11 by 2 root of 1285. So the right answer is option C. So this is basically how you should solve this kind of questions. If you get first draw the diagram and see whether they are parallel lines or they are intersecting lines. Based on that, if they are parallel lines, you have to essentially find out what is the distance between these two lines. Now let us take a look at the next concept, which is of Venn diagrams and maxima and minima of Venn diagrams. A lot of people know set theory, know how to draw Venn diagrams, but they actually struggle quite a bit when they have to calculate the maxima or minima in Venn diagrams questions. So we'll take the case of first the simple two set Venn diagram. So this is say set A, set B, and this is the universal set U. In this case, basically suppose this is 80, this is say 70 and this is 100. What is the maximum overlap of A intersection B? The A intersection B in this case, the maximum that A intersection B can be, this is limited by the smaller of the two sets. In that case, what do you say? That there is no all of AB that can be fit into A intersection B, I will try to fit. All of A that can be fit into A intersection B, I will fit. But I see that since this is 70, this value, this intersection value cannot be greater than 70 as such. So this part can be a maximum of 70, this will be 0 and then this will be 10 as such, which would mean that the outside which is not part of either of the sets becomes 20. So what is the max value of A intersection B in this case? This is equal to 70. Now there is a way of visualizing this. Basically, when you are maximizing the overlap between two sets, try to push them close to each other such that one set entirely becomes part of the other set. When you are trying to minimize the extent of overlap, try to bring them back outside as much as possible. So in that case, if I am trying to minimize the overlap, I say that this is u is equal to 100 and as far as possible, I make A intersection B as little as possible. So this is only A, this is only B. Now if I have to make it as little as possible, I see that A plus B is 150 and this is 100. So at the least I have to put 50 over here, 30 over here, 20 over here. I cannot pull them apart anymore, otherwise the sum will be greater than 100 as such. So visually you can see that there should be, if you are trying to minimize the overlap, you have to pull them away as much as possible so that the other parts of the set take up as much of the remaining room as much as possible. For maximizing overlap, I push one set into the other, that is the smaller set into the bigger set. If I think numerically of this, I can say that S be the number of elements that are part of only one set, D be the number of elements that are part of two sets, that is the overlap. So S plus D is equal to what? S plus D is equal to A union B, number of elements of A union B. What is S plus 2D? S plus 2D is basically if I add the number of elements in A plus the number of elements in B, I get S plus 2D. This is n of A plus n of B. Now n, or basically those not part of any set, I will call them n. So in this case, S plus D plus n is equal to how much? This is equal to the universal set. So when I take the difference between, say this is 1, this is equation 2, this is equation 3, what do I get? I get D minus n is equal to sum of the sets minus universal set U. Now essentially this sum of the sets minus universal set U is the overflow as such. That is, by what extent does the individual sum of the sets overflow above the universal set. And basically if it is, I consider this is 100, this is 80 plus 70, this is 150. So 150 minus 100, that is 50, I call it as overflow. That is basically something that cannot be fit into the sets if they are basically separate sets. If A and B are separate set, max they can actually add up to 100. But the fact that they are adding up to 150 indicates that 150 minus 150 is overflow, which is the minimum possible overflow. That means D min, that is the minimum possible overflow, is this n, that is not part of any set, plus this overflow as such. So D min will be equal to the overflow, which is what we found in this case, that is the minimum intersection is equal to 150 minus 100, that is 50. Then what is D max as such? D max is equal to the overflow plus n. So I have to find out what is overflow. Overflow is basically, in this case I have found that the overflow is 50. So 50 plus n will give me a value for the maximum value of D. Now instead of looking at it as that what value of n can I actually put, you have to also consider the fact that D plus n plus S has to be equal to 100. So using these two conditions, I can say that and also using this particular diagram, the maximum value of D is when one of the sets is completely consumed in the other set. So when you have to find out the maximum value of overlap in two sets, assume that the smaller set is consumed by the bigger set. If I have to find out the minimum value, I assume that I have to account for the overflow. Overflow is the sum of the set's cardinality minus the universal set. That has to be the minimum overlap. Now let us consider the same logic for 3 set Venn diagrams. This is where most students essentially struggle when they have 3 set Venn diagrams. So let's consider the same scenario in 3 set Venn diagrams. In 3 set Venn diagrams, I won't visualize the overlap, I won't do anything of that sort. In that kind of scenario, you should only remember S, D and T. So what is S, D and T? So in 3 set Venn diagrams, you say that let S be the elements which are part of only one set. Let D be the elements which are part of two sets, exactly one set, exactly two sets. Let T be the elements which are part of exactly three sets, which is over here. So this is T as such. This is say D1, D2, D3 are part of D. And then finally you have N, which is not part of any set, part of zero sets. Now what can you see over here? You see that S plus D plus T plus N is equal to the universal set, that is your the total value that is there. N is that is part of no set as such. The other condition that you have is S plus 2 times D plus 3 times T is equal to N of A. This is say A, B, C. When I add the individual cardinalities, those that are part of the single set are added once, those that are part of two sets are added twice, and those that are part of three sets are added thrice, because essentially we are double counting and triple counting the overlap. Overlap of two sets double counted, overlap of three sets triple counted. So the part of two sets are counted twice, part of three sets are counted thrice. So this is equal to N of A plus N of B plus N of C. Now I get another equation for overflow. So what is the other equation for overflow? D plus 2T plus N is equal to the sum of cardinality minus U. So when I have to actually say what is the maximum value of T, what is the maximum value, this is minus N. What is the maximum value of T, what is the maximum value of D? I have to use this overflow equation as such. So in this case, basically if I have to maximize the value of T, I have to consider what is the individual cardinality. In that case, T has to be lesser than the individual cardinality, first and foremost. Secondly, since it is 2 times T, the cardinality should be such that I cannot overflow this. This overflow has to be accounted for in such a way that this 2T plus N should be at least equal to the overflow as such. So when I am trying to maximize T, I should minimize D, because essentially D plus 2T is equal to some fixed value. So if I maximize T, D will get minimized. If I maximize T, if I consider this equation, okay, for every value of T, I am considering every value of T is accounting for two elements of overflow. So when I maximize T, I minimize D, and S plus T, D plus T is also minimized as such. So X is maximized. So when T is maximized, S is maximized and D is minimized. When D is maximized, S is minimized, T is minimized. This actually can be understood only with the help of an example, because in terms of equations of maximizing and minimizing, it is difficult to grasp this particular But just remember, when you are maximizing or minimizing Venn diagram sets, write down these equations first. S plus D plus T plus N is equal to the universal set. S plus 2D plus 3T is equal to the sum of individual cardinalities. The difference between these two equations gives you the overflow. Once you have the overflow, you have to account for it by D plus 2T minus N is equal to the overflow. So when you have to maximize D or maximize T, or minimize D or minimize T, or maximize S or minimize S, you have to basically do it with the restrictions of this particular overflow condition, this condition as such. These two conditions essentially put limits to how much can S be maximized, D be maximized, T be maximized. So let's actually understand how to actually do the process with the help of an example. So consider the following question. We have this question over here. A survey of 800 students was conducted to know about the liking of cricketers of students. It was found that 700 students like Virat Kohli, 550 like Rohit Sharma, and 300 like KL Rahul. Find the maximum number of students who liked exactly one cricketer if it is known that every student liked at least one cricketer. So what is essentially given? The universal set is 800. Then you have Virat Kohli, Rohit Sharma and KL Rahul. So Virat Kohli is 700. Then you have Rohit Sharma, which is 550, and KL Rahul is 300. And we are given that everyone liked at least one cricketer, which means N is equal to 0. Now if this is the condition and N is given as 0, then S plus D plus T, where S is the number of students who like exactly one cricketer, those who like exactly two cricketers, those who like exactly three cricketers, this is equal to 800. This is our first equation. The second equation that we have is, if I add up 700, 550 and 300, what do I get? I get S plus 2D plus T, 3T is equal to 1250, 1550. This is the second equation. So essentially I have to maximize what the number of students who like at least one cricketer. So I have to maximize the number of students who like exactly one cricketer. So I have to find what is the value of S max. So as I said, to find the value of X max, I have to find the value of T max. S max and T max occur together. When S max occurs, T max occurs, we get D min as such. This condition occurs together. So I'll try to maximize T, minimize D, and I'll find the maximum value of S in that kind of a scenario. So in this case, let us find out what is the overflow. So overflow D plus 2T is equal to how much? It is equal to 750. Now what is the max value that T can take in that case? T will be, suppose D is equal to 0, then T is equal to 375. But can T be equal to 375? Can this value be equal to 375? No, because KL Rahul has only 300 fans. Because he has only 300 fans, this cannot be 375. So that means that the max value T can take is actually limited by this value over here. So T max is 300. Which means that if T max is 300, D min, the minimum value D can take is when T is equal to maximum. So this is D plus 600 is equal to 750. So D min is 150. Now if D min is 150, T max is equal to 300. What is S max? S max plus D min plus T max is equal to 800. So this is equal to 800 minus 300 minus 150. So this is equal to 500 minus this. So this is equal to 350. So what is the maximum number of students who like exactly one cricketer? It is 350. Always remember, S max occurs with T max, which occurs with D min. S min occurs with T min, which occurs with D max. This is in the scenario when n is equal to 0. When n is equal changes, there is slight constraints to this as such. One more thing that you have to remember, whatever is the value of T max and T min are not only set by the constraint or the overflow constraint and the linear equations also, but also by the actual diagram. So always draw the actual diagram so that you have your eye on what values T can take, what values T cannot take. Again, T cannot be a fraction. So T cannot be something like 0.5. So if this was a odd number, by default D would have to be an odd number, so that 2 times T would be an even number as such. So always remember all of these aspects while you are solving questions of these type. Now let's take a look at the next concept, which is of derangement. So derangement is a very specific concept that comes from permutations and combinations. It is, you have to just basically remember one formula. If you remember that one formula, you will be able to solve a question that comes from derangement. So what is derangement? Derangement basically is the short form of disarrangement. If you have to basically say that there are, say, 3 rings and 3 pegs, say green, yellow, blue and green, yellow, blue peg. So green, yellow, blue ring and green, yellow, blue peg. And you have to basically say how many ways can we arrange the rings in the peg, where each ring is, one ring is on one peg as such. There is exactly one ring on one peg, such that none of the pegs have the same colored ring. So essentially there is one actual match, which is basically green is to green, yellow is to yellow, blue is to blue. So we are supposed to find out in how many ways can we arrange such that the actual arrangement of green to green, yellow to yellow and blue to blue doesn't occur. So that basically means if you have green to green and yellow to blue and blue to yellow, even this is wrong, because here you are supposed to find out where none of them are in the right place as such. When you have none of them in the right place, you get disarrangement. If one of them is not in the right place, then you have basically just consider that what is the total number of ways of arranging. That minus 1 will give you the number of ways in which 1 is out of place. But this is not that 1 is out of place. This is that none of the arrangements is in the right place. So if you have n arrangements, n letters in letter boxes, n letters in envelopes, n people and their water bottles. So if you have any kind of arrangement where there is one right arrangement, your derangement basically gives you the number of ways in which none of the people get their own water bottle. So essentially no one has their own water bottle. None of the letter lands up in the intended envelope. None of the names are with the right surnames. So this is basically disarrangement or derangement. There is a formula for derangement. That formula for derangement, you remember, this is essentially n factorial. So for derangement, instead of using like this, to indicate the derangement of n, you put the factorial sign ahead. So derangement of n is equal to n factorial divided by 1 upon 0 factorial minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial and so on till minus 1 raised to n by n factorial. So essentially if n is even number, it will be positive. If n is an odd number, it will be negative. See, this is equal to 1, this is equal to 1, so this is 1 minus 1. So you can ignore these two and start from 1 by 2 factorial as such. So what is this? Essentially n factorial divided into 1 by 2 factorial, 1 minus 1 by 3 factorial and so on till plus minus 1 raised to n divided by n factorial. So just remember this one particular formula for derangement. It is extremely important that should a question come on derangement, you should be able to answer it. So let's take a look at a question. So we have this question from derangement. So the question is, in how many ways can 6 letters be put into 6 letter boxes such that no letter is put in the correct letter box? So there is perfect disarrangement, that is no letter is in their correct letter box. So if that is the case, how do you actually find it out? This is basically we have to find out what is the derangement of 6. The number of disarrangements of 6 is basically 6 factorial into 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus 1 upon 5 factorial plus 1 upon 6 factorial. So this is 6 factorial into half minus 1/6 plus 1 by 24 minus 1 by 120 plus 1 by 720. So 1 half minus 1 by 6 is 1 by 1/3. So this is 1/3, this is 5 by 120 minus 1 by 120, so that is 4 by 120, so that is 1 by 30 plus 1 by 720. Multiply by 6 factorial, which is 720, so this is 240 plus 24 plus 1, so this is 265. So the number of ways of disarranging 6 letters is 265. So as you can see, this is very simple. Once we know that, we have to just use the disarrangement or derangement formula. So remember the derangement formula. If any question comes, this will be a very easy and quick question to solve so that you can get the right answer very quickly and move on to the next question. Now let's take a look at the second last concept or second last formula that you should remember, which is the number of integral solutions. Number of integral solutions is important from probability perspective. It is important from the perspective of finding how many equations exist for a linear equation, and it is also important from an LRDI perspective. When you have enumeration of cases, this tells you in how many ways something can be enumerated. So what is number of integral solutions? So basically, if you are given any equation of the form a plus b plus c plus d is equal to n, then and you are given that a, b, c, d are non-negative integrals, that is they are greater than or equal to 0, and obviously they will have to be less than or equal to n because they are non-negative integrals. Then the number of ways then that they can add up to n, the number of ways that a, b, c, d values can take such that they add up to n is given by n plus r minus 1 c r minus 1. Here r is the number of variables, which in this case you have 4 variables a, b, c, d. N is the sum that it is adding up to, so that is the RHS of the equation, and n plus r minus 1 c r minus 1 gives you the number of ways in which, or number of solutions, number of integral non-negative integral solutions for this particular equation, or if you can say in how many ways can this occur such that the sum of the distribution is n. So the number of non-negative integral solutions for this particular equation is given by n plus r minus 1 c r minus 1. Now suppose that it is not just non-negative integral solutions but positive integral solutions. So suppose it is given that a, b, c, d should at least be 1 as such. So a, b, c, d should not be greater than 0 but should be at least 1. Then in that case we have to find out the number of non-negative integral solutions. If you, we have to find out the number of positive integral solutions. Positive means that a, b, c, d should at least be 1 as such. So in that case we have a other formula which is n minus 1 c r minus 1. There is a very quick way in which you can actually figure out it should be like that. Is basically that if this is can be 0 or 1, and now here you have to at least have 1. So from this n, consider that 4 are already put in a, b, c, d slot. If 4 are already put in a, b, c, d slot, then the remaining n minus 4 can be distributed in any way that is needed. So then it would be n minus 4 plus 4 minus 1, that is n minus 1 C1. So that is basically how we get. This will be basically n minus r plus r minus 1 and c r minus 1. So we get n minus 1 c r minus 1. So when you have to find out the number of non-negative integral solutions, it is this. That is, it can be 0 or greater. It has to be n plus r minus 1 c r minus 1. If it is positive integral solutions, it has to be this. So let's take a look at a question based on this topic. So consider the following question. In how many ways can 18 identical balls be distributed among 3 girls such that each one of them gets at least one ball and no 2 girls get the same number of balls? So we have that a, b plus c is equal to 18. In this case, a represents the number of balls with the first girl, b represents the number of balls with the second girl, and c represents the number of balls with the third girl. The sum of their balls should add up to 18. Also, we are told that A, B, C should at least be 1, they should get at least one ball and no 2 should get the same number of balls. Now, if you remove this condition that no 2 girls should get the same number of balls, without that condition, it becomes a question of finding the number of positive integral solutions. So, without that condition, let us first calculate and then we will consider the cases where that condition is violated and remove that from the total as such. So, without this condition, how do you get, how many solutions that you get? That will be number of ways would be n minus 1 c r minus 1. Here n is 18, r is equal to 3. So, this is 17 c 2. So, that is 17 into 16 by 2. So, this is 8. So, this is 56. So, this is 136. So, without a condition that no 2 girls get the same balls, you can distribute them in 136 ways. Now, let us consider in how many cases do 2 girls have the same balls. So, in this case, consider that A is equal to B and not equal to C. If A is equal to B and not equal to C, then you can say that A can be equal to 1 and B can be equal to 1 and C can be equal to the remaining, that is 16. Similarly, A can be equal to 2, B can be equal to 2 and C can be equal to 14 and so on. When A is equal to 6, B is equal to 6, C is equal to 6, this condition we will remove because then all 3 are equal. Now consider A is equal to 7, B is equal to 7, C is equal to 4, A is equal to 8, B is equal to 8, C is equal to 2. Now in the next scenario, A is equal to 9, B is equal to 9, C becomes 0, which violates the condition that they have to be at least 1 as such. So the number of cases is basically removing this one where A is equal to 6, B is equal to 6, C is equal to 6. We get 8 minus 1, that is 7 cases. So this is 7 cases as such, but in this case we have considered A is equal to B, but we can essentially consider any of the 3 girls has the unequal number of balls. So that can be selected in 3 ways, or essentially 3C2, that is out of the 3 girls we have to select 2 girls who get the same number of balls. 3C2, that is from 3 we select 2 girls who get the same number of balls. That can be done in 3 ways. So the ways of arranging A, B, C in all of these cases is 3 essentially. So this is 7 into 3 ways. In these 21 cases, our condition is violated. So from this I have to remove 71 cases. There is also one condition in which A is equal to B is equal to C. When A is equal to B is equal to C, then again this condition is violated. That is when A is equal to 6, B is equal to 6, C is equal to 6. The number of ways of arranging this particular case is only 1. That is, we give 6 balls to all of the 3 girls. So this is also just one case. So from 136, I remove 21 when 2 girls have the same number of balls and 1 has different number of balls, minus 1 when all 3 have the same number of balls. So 136 minus 22 is 114. So how many ways can you distribute? You can distribute in 114 ways. So always remember, first start with finding out the base value of number of integral solutions. From that, remove all the cases where the particular condition is violated. Now let's take a look at the last theorem that you should remember. This one is from probability. It also has a lot of application in finding out the probability, complex probability, when you have multiple trials of something. So suppose a shooter is hitting at a target multiple number of times, or if you are playing a game of dice is going on and the dice is thrown multiple number of times, or a coin is tossed multiple number of times. In that case, if you have to find out how many times something exactly happens, that is, out of 5 coin tosses you get exactly 2 heads, or out of 5 shots that are fired by the hitman, exactly 2 hit the target, or if a pair of dice are thrown, exactly twice the sum of the dice is equal to 10. So in those kind of scenarios, what you do is basically you find out the total combined probability of multiple successes, or x out of n trials being successful using binomial theorem. So if I say that you are out of n trials, x succeed and n minus x trials fail, and the probability of success is say p, then the probability of failure will be 1 minus p. Then what is the probability that exactly x out of n trials will succeed? So probability of x out of n trials succeeding, according to binomial theorem, this is given by ncx, that is out of n you select x, ncx p raised to x 1 minus p raised to n minus x. P raised to x gives you the probability of x scenarios actually being successful. 1 minus p raised to n minus x tells you the probability of the other n minus x scenarios being a failure. So the probability of x out of n trials being successful is given by this theorem, which is called as the binomial theorem. Ncx is equal to p raised to x into 1 minus p raised to n minus x. So let's take a look at a quick question based on this topic. So let's take a look at this last question. Bombs are fired on a bridge such that the probability of a bomb hitting the bridge is 0.5. A minimum of 2 bombs are required to hit a bridge in order to destroy it. Find the minimum probability of hits required such that the probability of destroying the bridge is greater than 0.8. So in this particular case, what is the probability that is required? That you have to destroy the bridge, probability of destroying the bridge. So probability of destroying the bridge in n hits, okay, probability of destroying in n hits, this is equal to 1 minus probability of not destroying in n hits. So if you are not destroying in n hits, that means out of n hits, less than 2 are actually hitting the target, not destroying in n hits. Now less than 2 are hitting the target means that either 0 is hitting the target or 1 is hitting the target. So this means that I have to consider the case where none of the bombs actually hit the target. So that means that all of these n bombs miss the target. In what is the probability that all of these bombs miss the target? Probability of hitting is 0.5, is half, and probability of missing is also half. So that basically means that if it misses n times on the trot, the probability of them, the bombs missing the bridge n times is basically half raised to n. Now I have to consider the probability of hitting the bridge exactly once out of n trials. So exactly once out of n trials would be nc1, probability of hitting is half, and probability of missing it in n minus 1 trials is half raised to n minus 1. So this has to be greater than 0.8. This has to be greater than 0.8. So we have to find out the value of n such that this is greater than 0.8. So this, if I find, this is essentially n plus 1 times into n plus 1 times half raised to n. nc1 is nothing other than n, so this is n plus 1 times half raised to n. So this has to be less than 0.2. So essentially n plus 1 divided by 2 raised to n has to be less than 0.2 as such. Let us consider the scenarios 1, 2, 3, 4, 5, 6 quickly. If we consider 7, if we consider 3, I will just try to see at what point this inflection occurs. This will be 4, if n is equal to 3, this is 4 divided by 8, so that would be 0.5 as such. So 0.5, so this is, I can remove all the cases. See, remember, as 2 raised n increases, this increases linearly, this increases exponentially. So your value of this function is going to fall like this as n increases. So at 3 it is equal to half, so that is obviously not actually satisfying the condition. At n equal to 4 it will be 5 divided by 16, which is close to 3 point, that will be basically 5 by 16 will be equal to how much? 5 by 16 is, this will be equal to 4.5.0 is basically, this is 3.3 something something. So it will be basically not less than 0.2. So I can eliminate the condition. So even n equal to 4 is not the case. At n equal to 5, this is 6 by 32. 6 by 32. Is this less than 0.2? If I consider, I take 32 over here, this is 6.4, 6 is less than 6.4. So at n equal to 5, this condition is satisfied, this inequality is satisfied. So what is the minimum number of value of n? Minimum value of n is equal to a, that is n has to be equal to 5. After 5 hits, the probability of it destroying the bridge is at greater than 80%. So the right answer is n is equal to 5. So as you can see, there are many formulas that you tend to forget, that you don't use that often, but are still important from the perspective of CAT. I hope this was helpful, and this gets you helps you in identifying any blind spots that you have in your preparation. If at any point of time in this particular video you didn't know a concept, didn't remember a formula, or found there was a gap that you couldn't answer as such, please actually visit the concept videos, see the concepts or underlying concepts, so that you know for sure what all formulas require you need to remember as such. So these are the most important 20 CAT formulae that people tend to forget, but are very important from the exam perspective. Now that you have seen this video, please make sure that you keep practicing from mocks and you keep attempting questions. Thank you so much for watching our video.